132 participants have still joined, so around 330 participants, and we are expecting, because on an average 330 340 participants are expecting to, because as there is a lunch break, so that's why they are again joining. So just wait for another 2 minutes and then we shall start, sir.
Sure.
So it is 2 now, so I think we should start. So thank you so much, sir. Thank you for your thank you so much, as you have agreed to provide a valuable lecture for our participants. I am sure our participants will definitely learn many things from your lecture, and thank you so much once again. So dear participants, this is the second last lecture of this conference, total 16 lectures. So this is the 15th scientific lecture. So Professor Muthaban Ashok Kumar sir will deliver his lecture on ultrasonics and sonochemistry as a green technology for functional materials and bioprocessing. So definitely in few lectures we learned many things about microwave, but this time, so solely is very. I think it will be. I am sure this will be very interesting for those who are working with ultrasonic sound-assisted reactions. And let me introduce sir, Professor Ashok Kumar is from University of Melbourne. Is the Assistant Vice Chancellor of International chapter, and he is from Australia. Professor Muthapan is a physical chemist who specialized in sonochemistry, teaches undergraduate and postgraduate chemistry, and is a senior academic staff member of the School of Chemistry, University of Melbourne. He is currently the Assistant Deputy Vice Chancellor International at the University of Melbourne. Professor Muthapan is a renowned sonochemist with about 25 years of experience in the field. Can you imagine? And has developed a number of novel techniques to characterize acoustic cavitation bubbles, and has made major contribution of applied sonochemistry to the materials, food and dairy industry. Now, his research team has developed a novel ultrasonic processing technology for improving the functional properties of dairy ingredients. Recent research also involves the ultrasonic synthesis of functional nano and biomaterials that can be used in energy production. He has published more than 470 research journals, and all are in highly impacted journals. So with this short introduction, I'm again welcoming you, sir. I don't want to waste your time, your valuable time. So you please share your screen now, share your lecture slides now. We have made you the co-host. Yeah, now it is. You please make it as a full screen. Yes, sir. Yes. Yes, sir. Thank you so much, sir. Thank you so much once again. Thank you. What do you, sir?
Thank you, Dr. or Professor Banerjee. I hope you can hear me properly.
Yes, sir. Yes.
Okay. And also, it's very kind of you to invite me to give a lecture at this conference, but also I really appreciate for this opportunity. And also thank you for kindly introducing me with my credentials. So today I will be talking to you, or also thank all the participants for their attendance. Today, as mentioned by Professor Banerjee, I'll be talking to you about my research work on ultrasonics and sonochemistry, how ultrasound can be used for various chemical reactions, but also for some applications. And I'll try to kind of cover maybe around 45, 50 minutes of the content, and then we'll have some time for some questions. But before I talk about my research, I thought I'll just briefly introduce my university to you. I'm from the University of Melbourne. As you can see, it was established in 1853, the second oldest university in Australia. And I have two roles in the university. I'm an academic staff member as a professor at the School of Chemistry, where I do teaching and research. And also I have another role at the Chancellery at the University of Melbourne as Assistant Deputy Chancellor International, taking care of some international engagement aspects. And you can see some of the buildings that we have. Some of them are colonial, built in early 1900s or even before, and some majority of the new buildings are a bit modern, as you can see here. We have about 7 campuses in Victoria. Victoria is the state where Melbourne City is located, which is around about southeast corner of Australia, as you can see in the map. And the main campus is the Parkville campus, which is the photograph of the Parkville campus you can see here. And the entrance of the Parkville campus also you can see here. And we are located about 10 minutes walk from the city center towards the north. And majority of our departments and schools are kind of scattered here. And what you see is the colleges, and when I say colleges, these are the hostels for the students from international and interstate areas. And we also have some more research buildings around here, majority of them in biomedical and medical area. The rest of the campuses, South Bank and Werribee, etc., they are more purpose-built. For example, the Werribee campus is for veterinary science. And so because they need a bigger land, it's kind of that's built a little bit away from the city center. And we are a comprehensive university. What I mean by comprehensive university is basically we teach everything. We do research in every area that includes engineering, science, medicine, law, everything that you can think of. So in terms of the Times Higher Education ranking, we are #1 in the past, for the past maybe 10 years in Australia. Globally, we are kind of ranked anywhere between 30 and 35, depending upon which ranking that you look at. Based on the Times Higher Education ranking this year, we are ranked #31 globally. We have about 70,000 students on campus, but maybe in 2020 and 2021, most of them are studying online because some of them are stuck overseas, some of them are interstate. But we do have half of the students in Melbourne. But even then, we don't have many classes face-to-face. Majority of them are still through online process. And out of this kind of 70,000 students, we have approximately 40% international students, primarily from China, but we do have the second highest number from India. So that kind of introduction to my university, I'm trying to introduce my team. And most of the work that I'm going to share with you today, there are some of the learnings that we learned together, either with my PhD students or master students or postdocs or through my collaborators. So I'd like to, at the outset, acknowledge all of them for their contribution for the data that I'm going to share with you in the next kind of 40 minutes or so. And most of us know what ultrasound is. basically, sound waves that we cannot hear. That's how we can refer to them. The frequency range of ultrasound is above the human hearing, approximately more than 20,000 hertz or 20 kilohertz. And below 20 hertz, sorry, 20,000 hertz, humans can hear. The upper limit can be based on the age. Some of us can hear up to 22 kilohertz. Some of us can only hear up to 16 kilohertz and so on. And you can see that below the human hearing, we have infrasound. Some animals use them for communication. Above human hearing, the ultrasound also can be used for by some animals for communication or other purposes. And majority of you will be knowing ultrasound through the ultrasound scanning. You can see a picture here. And what we are going to look at is, how we can use this kind of ultrasound for, doing some process applications or doing some synthetic applications, and why we consider it as a green technology compared to other processes. That's what we are going to learn. And because of the time limitation, I won't be able to go too much into the basic aspects or the fundamentals of what we call this process, acoustic cavitation. But basically, the acoustic cavitation is responsible for many of the applications that we are going to look at in the next kind of 40 minutes. In simple picture, so what we have is when we have a liquid with full of bubbles, if you have dissolved air, you will have some dissolved bubbles in there. And if you pass ultrasound through those liquid, the bubbles in the liquid will start interacting with the sound waves or start responding to the pressure changes that's happening. And as we know, sound waves are just kind of oscillating pressure waves. So when the bubbles experience the expansion cycle or the rarefaction cycle, they respond by expanding. When the compression cycle of the ultrasound comes through, then they compress, and basically they start oscillating in response to these sound pressure waves. But what you can see in this schematic diagram is not only that they are oscillating, but they are also growing in the size, and that's through a process what is known as rectified diffusion process. And again, I'm not going to go through the details, but you just need to accept that the bubbles are oscillating and growing in size. And once they reach what we call a resonance size range, and the resonance size can be anywhere between a few micrometers to up to 100 micrometers, depending upon the frequency that we deal with. Once they reach the resonance size, then they start collapsing near adiabatically. And what you see in this video clip is a single bubble that is trapped in an acoustic field, and you can see the growth and collapse of this bubble. And what you have to at this stage note is that the size of this bubble, when it is maximum, is around 100 micrometer. The frequency that we are operating at for this particular case is 20 kilohertz. And what is important here is that you can see the bubble is growing slowly. When it is collapsing, it collapses very fast. That fast collapse, which happens within a microsecond time scale. So for a 20 kilohertz, the overall acoustic cycle is about 50 microseconds. The collapse is happening within a microsecond, and that fast collapse can be considered as an adiabatic collapse. And some of you may have some chemistry knowledge. An adiabatic process means no heat or energy transferred to the surroundings. So when the bubble is changing its volume, collapsing, that volume change, again, in terms of thermodynamics, any change in volume is associated with work. W is equal to P delta V. So in this case, all this work is converted into heat for a very short fraction of a time, maybe for less than a microsecond. And that heat can be substantial amount. So that's kind of summarized here in my next slide. You can see that when the bubble is collapsing inside the bubble, the temperature can reach anywhere between 5,000 to 15,000 Kelvin. And that means, during these oscillations, when the bubbles are expanding, water molecules or solvent molecules and solute molecules can move into or diffuse into the bubble. So when you have large amount of heat and chemical species like water or oxygen or nitrogen kind of things, then you can initiate chemical reactions. And that's what sonochemistry is about. So here, as you can see, we are simply generating radicals. For example, water can decompose to form hydrogen atom and hydroxyl radicals. And these radicals are generated simply by heating the water in a bubble. And we are generating redox species without using any chemicals, any other chemicals. And that's why we call this as a green process, so that we can do some chemical reactions in the absence of added chemicals to the systems. So that radical generation generates sonochemical reactions. And something that's happening here is called sonoluminescence, which is simply light emission. I'm not going to talk about that today. But what also happens is, due to the pressure that is generated, when the volume is decreasing, you also generate large amount of pressure. That pressure after the collapse is released back into the system as a shock wave, and that can increase the mass transfer. And again, if you remember what you learned in chemical kinetics, if I want to increase rate of chemical reactions, then one of the parameters, which is your rate constant, that has a term called collision frequency, collision between molecules. So the shock wave or any other shear forces that we generate when the bubbles are oscillating, that can be used to increase the mass transfer and hence to increase the chemical reactions. Again, no catalyst added. It's a simple oscillation process. Again, we can consider that as a green process. The picture that you see here, the bubble is collapsing asymmetrically, generating a microjet. That jet has very high energy that can also make, for example, small holes on particles. So for example, if I have a metal or a catalytic particle that I want to increase the surface area, then simply I can sonicate that and make some porous structure. Increasing porous structure means increasing surface area. That means you can increase the catalytic reaction efficiency. Just to give you how strong this kind of physical forces when the bubbles are generated. Again, I have a video clip. Hopefully it runs so that you can see what's going on here. So you can see I have a capillary around 400 micrometer. A bubble is trapped on the wall of the capillary, and I have water with some slurry, silica particles. When the bubble is oscillating very fast, so in this case it's around 400 kilohertz, you can see the force that is generated is experienced by the whole slurry, and the particles are pushed very strongly. And assume that instead of particles you have molecules. Basically these molecules will be moving around very fast. That's where you can increase the mass transfer and hence chemical reactions. The second video clip that I'm going to show you is again to show that we can use this for making emulsions. In particular, for example, food emulsions. In food industry, ultrasonic emulsification is used to make very fine emulsions that have specific properties for certain applications. So in here, what I have is I have a little bit of water, I have some oil, and I have an ultrasonic horn coming from the top, and that is placed right at the interface. So as soon as I turn on the ultrasound, you will see a nice emulsion being generated. Okay. That emulsion can be used, for example, for various applications. So what what I have shown in the past couple of slides is that you have strong physical forces generated that can be used for some applications that I will highlight later on. And also, as I said, if I have water molecule inside the collapsing bubble, I can generate hydrogen atom and hydroxyl radicals. And hydroxyl radicals, as you know, are oxidizing agents. Hydrogen atom or reducing agent. I can do redox reactions using this kind of radical species. And that's what I told you, that this is a green process to do chemical reactions because we don't need to add extra chemicals to initiate chemical reactions. With that kind of very, very brief overview on the introduction part of my of the acoustic cavitation process, Today, I will be more focusing on making some functional materials and also for some bioprocessing applications. So, we looked at some basic aspects. So what I have shown you is some of the basic understandings that we have developed over a 10-year period when I started working in this area in two or three slides that I gave you. And beyond that fundamental understanding, my research is focusing on using these kind of physical and chemical processes for applications in energy, environment, health, and food. But today we are not going to look at all the applications. We will be looking into some functional materials, how we can make them using this kind of green technology, and how we can use that, for example, in food processing and biomedical applications. Just to give you a very, very simple example, I can use the reducing radicals that we generate, like hydrogen atom or any secondary radicals, for making metal nanoparticles. Most of you know that metal nanoparticles are used in a variety of applications, including biomedical applications. So I'm just kind of giving you one example where if you take, say, gold chloride, so this AU here is gold chloride, and the gold has 3 oxidation states. So if I add 3 hydrogen atoms through this process, I can generate gold atom. Gold atom then can agglomerate to form gold nanoparticles. I can follow this process simply by following the absorption spectroscopy. The gold nanoparticles, they have specific absorption, plasma absorption band around 530 nanometers. Okay, so a very simplified mechanism. I don't want to go too much into the details, except that I want to show that I can use the radicals that we generate using this acoustic cavitation process to generate metal nanoparticles. You can see that I can make metal nanoparticles with different shapes and sizes. And also, by using my chemistry knowledge, I already told you that hydroxyl radicals are oxidizing agent, but I can convert them also for reduction processes by using small amount of like ethanol or any alcohol or any organic molecule. So what happens is both hydrogen atom and hydroxyl radicals react with this solutes to generate secondary radicals. The alcohol radicals that we have, the ethanol radical, for example, is a reducing agent. So simply I can convert the oxidizing agent into a reducing agent, but also I can do oxidation reaction by doing the opposite. If I have oxygen in the medium, oxygen can react with the hydrogen atom to generate peroxy radicals, then I can only do oxidation reactions. So by, again, using my chemistry knowledge, I will be able to manipulate the system either to do pure reduction or pure oxidation reactions. So here, I'm just showing that when I have alcohol, for example, I can generate more gold particles because I'm converting the hydroxyl radicals into a reducing agent. But that's, you can always ask this question. You don't need to always go for sonochemical method to make metal nanoparticles. You can use some chemical methodology. For example, if you take sodium borohydride, you can use sodium borohydride or any other chemical reducing agent to make the metal nanoparticles much faster, much quicker. But then it is not going to be considered as a green technology because you are adding a chemical species to as a reducing agent. But also, there are some specific applications you cannot use even the chemical reducing agent to make these kind of metal particles. That I will show you an application for that. Okay. So what I'm showing in this particular plot is how to control the size of the particles that we generate. For some applications, I have to make these particles 5 nanometers, 10 nanometers, or 50 nanometers. So the question here is, how do I control the size of these metal particles that I make? And for that, as you can see here, I can simply control the rate of reduction by controlling the frequency that I'm using. That will ultimately control the size of the particles. Those who are working in nanomaterials or any kind of materials, if you look into the process, the size of the particles can be controlled by two two methodologies. For example, the nucleation rate and growth rate. So these are the two parameters that will control the size and size distribution of the particles. If the nucleation rate is faster than the growth rate, you get smaller particles, okay, and the vice versa. So what you can see here is this this plot here shows how much of radicals that, so the hydrogen peroxide here represents a product that is made of hydroxyl radicals. So we can use the hydrogen peroxide quantification as a measure of the radical production. And what you can see here is where the amount of radicals produced is very, very small or very low at 20 kilohertz, very low frequency. When I go to 300 kilohertz, I produce more radicals. When I go to too high frequencies, then the radical production decreases, okay? I can spend maybe half an hour by trying to explain to you, but you just trust at this stage that we have an optimal frequency of around 200 to 600 kilohertz that are good for chemical reactions. And also the low frequency, as I already showed you, if I want to do some emulsification, especially when you are dealing with food applications, they don't want to have radicals. So in that case, I can use low frequency with less free radicals, but more processing applications. I will highlight that later on. But in this particular example, we are simply trying to control the amount of radicals produced, because by controlling the amount of radicals produced, you can control the nucleation rate. That means you can control the size of the particles. Okay, that's the kind of lesson that you have to remember. So what you can see here is that the size of the particles is dependent upon the frequency, but in reality, it is dependent upon the amount of radicals that we generate, okay? So if I want to make small particles, I have to go to the frequency range 200 to 600 kilohertz, where I generate more radicals. And again, I'll try to give you some quick picture of why it is. Or if I want to make bigger particles, then I go to low frequency or very, very, very high frequencies. In fact, simply the size of the particles can be controlled by the rate of reduction or the rate of nucleation, okay? And you know, the reason for why the radical yield is changing as a function of frequency is a combination of number of bubbles involved and also the number of radicals generated per bubble. So it's a combination of two different things. For those who really want to understand the mechanism, I'm happy to send some papers later on if you contact me that goes through the detailed mechanistic aspects. Today, my focus is primarily to give you some applications that may be useful for you, and then you may try to read some more papers to understand the basics behind it. So I told you that we can always use you know, sodium borohydride or any other chemical reducing agent, but what I'm going to demonstrate now is that for a particular application, sonochemistry is the only option for you to make the reduction process. For that, I'm just going to give you an example of methanol fuel cell. So in methanol fuel cell, the way it operates is basically you are doing some redox reaction using two electrodes. They both are carbon electrodes, and they both will have some metal particles deposited on them, particularly platinum, in order to promote the redox reactions, the electron transfer reactions, okay? And the mechanism is provided here. Basically, what you are doing, you are trying to oxidize methanol to generate carbon dioxide and water end of the day. During that process, you have some electron movement that leads to the generation of energy here, or the fuel here, okay? So conventionally, early days, methanol fuel cell electrodes are deposited with platinum nanoparticles. So the job of the platinum nanoparticles is that the methanol gets absorbed on the surface of the platinum, and then the the redox process happens. And during that process, you get the carbon monoxide as an intermediate product, okay? But what happens is the carbon monoxide has a very, very strong affinity to platinum. So it's stuck to the platinum surface, it does not leave. So this reaction stops here. And that means the platinum or the electrode gets poisoned and the fuel cell becomes inactive. And again, based on some electrochemistry knowledge, people who are working in this area, they know now that instead of having just pure platinum, if you have platinum ruthenium alloy, then having a ruthenium atom next to the platinum can convert the carbon monoxide into carbon dioxide. That reaction is promoted. So rather than having platinum metal particles, if you have platinum ruthenium alloy metal particles, then the methanol fuel cell becomes more active, does not get poisoned. So the idea here is how to make a platinum ruthenium alloy particle. Okay, we can go back to this technique that we know. For example, instead of taking gold chloride, I can take platinum chloride and ruthenium chloride and try to reduce them with the hope that we will form platinum ruthenium alloy particle. At this point, I wanted you to have a proper think about what exactly it is involved. If I want to make an alloy of two metals in a bulk process, I can melt both, for example, platinum, I can melt it, ruthenium, I can melt it. I can then mix them together and then let them cool. During this process, you will form an alloy, but that's a bulk metal alloy, okay? Here, we are not talking about bulk, we are talking about 2 or 5 nanometer particles, nanoparticles, that are alloy particles. So here, you cannot melt the platinum nanoparticle and ruthenium nanoparticle. It's difficult because they are, as soon as you melt, they won't be existing as nano size. They will be then fusing together to form bulk metal, okay? So in this particular case, we are trying to use our ultrasound generated, or the acoustic cavitation generated redox couple, or the reducing agents to form an alloy particle. So when we first tried this, what we got was basically we got a core shell particle, a platinum core with a ruthenium shell. That's not an alloy, but it is a core shell particle, which we did not want. But that's an interesting result that I wanted to show you. So the problem then we found was that platinum ions are easily reduced. The reduction potential of platinum is lower than the reduction potential of ruthenium. So the rate of reduction of platinum is higher than the rate of reduction of ruthenium. As soon as we identify that as a problem, so basically this shows that you form the platinum particles first, and once you consume all the platinum ions, then you form a ruthenium shell around it, which we don't want. And as soon as we identified that it is we need to make the rate of reduction of platinum equal to rate of reduction of ruthenium, then we can play with the chemical kinetics. We cannot change the rate constant, but we can change the concentration of the reactants. So by playing with by using our chemical kinetics knowledge, we were able to then adjust the reaction conditions, and then we were able to make 2 nanometer platinum ruthenium alloy particles, and then they could be used in the methanol fuel cell to show that they do a proper redox reactions. Okay, so you can see that the other thing that I want to tell you is sometimes we study chemical kinetics in first year or thermodynamics in first year, but some of those basic learnings that we do at the undergraduate level or postgraduate level can be used, that knowledge can be used to resolve a major research problem. Simply, that's what we have done here. Okay, so that's another lesson. The other thing that you some of you working in the metal particles, not only that you have to worry about the size, for some applications, you also need to worry about the shape of the particles. So we try to, for example, use different kind of various arrangements. In this case, we used what we call a high intensity focused ultrasound, which is heavily used in therapeutic ultrasound. For example, they use this in breaking kidney stones or blood clot kind of things in biomedical applications. But we use the same kind of arrangement to make particles that are having different shape. What we could see is when we use this HIFU, And by adjusting the different power level, we can either make spherical particles, or we can make octahedral particles, or we can make rod-like particles or cylindrical particles. And as you can see, having different shape or shapes, they give you different color, meaning you can use them for various optoelectronic applications. Okay, so again, people working in this area, they know that controlling the size and shape are important, and we are able to do that using sonochemistry. Recently, we have been also looking at the shape control. This is very, very recent. I just got accepted in one of the ACS journals, where we can also use some biofunctional molecules like tryptophan to make some two-dimensional shaped molecules, like triangular particles or octahedral particles kind of things. You can see the two-dimensional particles. We are not fully successful in making 100%, but at least we can make like majority of them having a particular shape with a two-dimensional morphology, and that can be used for, again, some specific applications. The other quick example before I move on to the biomedical applications, I think we only have another 15 minutes or so, is that we can also use the low frequency ultrasound where we get the strong physical forces, the high frequency ultrasound where we have strong chemical forces to make, for example, the graphene oxide exfoliation of the graphene oxide sheets with simultaneous deposition of some metal particles, in this case, gold particles. Remember that methanol fuel cell, we use carbon electrodes. Instead of using carbon nanoparticles, for example, if you use the graphene oxide sheets, two-dimensional sheets, they have much larger surface area. So people are now trying to use this kind of graphene sheets for catalytic applications and also for electrode materials. So in this particular case, we are simply demonstrating that using our dual frequency system, we are able to not only exfoliate to make two-dimensional graphene oxide sheets, but also simultaneously depositing metal to increase the catalytic activity. The next example that I'm going to show you is how to make polymer nanoparticles that are functional. I already showed you the video clip of an emulsification. So we can use the same process for making emulsion polymerization. Again, this is another green methodology. If you try to make a polymer, emulsion polymer or conventional polymer, bulk polymer, you always need to add a chemical initiator. Okay, and then the chemical initiator initiates the reaction, the polymerization process. But we can make the polymers without adding external initiator using ultrasound, because we are generating our own initiators. For example, the radicals that we have, hydrogen atom or hydroxyl radicals, they can be used to generate, to initiate the polymerization process. So in this case, what we do, the shear forces that we generate during the cavitation process break down the monomer into smaller droplets. That's how you make an emulsion. And once you make the smaller droplets of the monomer, then the radicals that you generate can be injected into the monomer droplet, and a monomer droplet can be converted into a polymer particle. So you can see that without adding an external reagent, we can still do the polymerization process. And this kind of polymer that we make have high molecular weight, and they can be used, for example, in paint industry to stabilize the paint and increase the durability of the paint and so on. But the example that I wanted to show you today is to make these polymer particles functional. The functionality that we are going to introduce here is magnetization, and making these polymer particles magnetically active. The idea was, the proof of concept study was that then we can use this magnetically active polymer particles if they are biodegradable for magnetic resonance imaging, MRI imaging kind of applications. That was the kind of concept. So simply what we do, we take some magnetic particles like iron oxide particles, disperse them into the monomer, and then we make the polymer as I showed here. And once you make these polymer particles, you can see the polymer particles have large amount of magnetite or magnetic particles deposited, and the whole colloidal solution then becomes magnetically active. Okay, and what it means is, instead of using a conventional monomer, if I use a monomer that is acceptable to our body, then we can use a similar approach to make MRI imaging. We can make magnetically active particles for MRI imaging purposes. The next example that I'm going to move in is more into biomedical applications. The first thing that I'm going to show you is how to make nanoparticles using polyphenols, and that have either nutritional value or maybe to use them as for biomedical or drug delivery applications. And majority of us know that, or most of us know that, polyphenols are there in fruits and vegetables that we eat. And polyphenols are good antioxidants, but also they have other functional properties. So the recent research involves, for example, extracting these polyphenols from natural resources like fruits and vegetables, and then encapsulating them into conventional capsules that when you eat the capsules, you assume that the polyphenols will be absorbed into your system and so on. And what happens is, if you simply add this kind of extracts into capsules, whether they stay in your stomach long enough for them to be absorbed by your system, that's not clear. But what people have done in recent research is, if you convert them into some nanoparticles, or convert these polyphenols into polymeric polyphenols as nanoparticles, then they have better efficiency in terms of absorption into your body. So a large amount of research is currently happening. So what we have done again is another proof of concept study to see whether we can use ultrasound to convert polyphenols into polyphenolic nanoparticles. Okay, so this is a busy slide, but in simple term, what we do is we take this kind of bioactive polyphenolic compounds, and they have this kind of tyrosine moiety. And when we sonicated this using high frequency, because here we are trying to do some oxidation or adding some hydroxyl groups into this to make this kind of nanoparticles. So I'll try to kind of go through that a little bit slow so that you can understand what's happening here. This is the parent compound. After sonication, this is our HPLC data, high performance liquid chromatography data. So you can see that after sonication, we generate hydroxylated compounds. And then we also get some high molecular weight dimers and trimers. Okay, that can also be seen by the mass spectrometric results. We have dimerized and hydroxylated products. So simply what happens is, I'll maybe try to go through the mechanism so that you can understand. We have the hydroxyl radicals generated during sonication abstracting a proton to form this kind of phenyl radicals, or phenoxy radical converted into phenyl radicals. That leads into this kind of dimerization process, ultimately trimerization and oligomerization and polymerization process. For this, not only that you need the hydroxyl radical, the generation of the phenyl radical is a high energy process. The activation energy is very high. So this whole process happens at the cavitation bubble interface, where the high temperatures that you generate helps to overcome this activation barrier. Okay, so once you start doing this dimerization, trimerization kind of things, you decrease the solubility as the molecule becomes larger and larger. The solubility becomes lesser and lesser, and once the oligomer reaches a solubility limit, then they all collapse into this kind of spherical structures. You can see anywhere between 100 nanometers or 200 nanometers. Now, these kind of nanoparticles then can be incorporated into food matrices. For example, you can add them into yogurt or fruit drinks kind of things to increase the polyphenolic intake into your body, to increase the nutritional value of these things. But also we can use them for drug delivery applications. Okay. The last application in the next 5 minutes that I'll be focusing upon is what we call encapsulation of nutrients or flavors or drugs for various biomedical and health applications. So what we can do is, I'll come back to this the slide after this slide. So we take some biopolymers like proteins, carbohydrates, anything, and they basically then get using sonication process, we absorb them into either air-water interface, or also if it is an oil, like an emulsion, oil-water interface, and then simply we cross-link these proteins to form a shell. So basically what you can see here is a protein or biopolymer shell. Within that shell, I can encapsulate anything. For example, I can encapsulate fish oil, vitamin, or a drug, or any other nutrient, or any other flavor for various applications. Okay. Once you encapsulate them into this kind of shell, they are completely protected from the environments. For example, if I take fish oil, and if I try to mix fish oil or vitamin with a food ingredient, like juice or yogurt, because the juice and yogurt will have oxygen, they are prone to oxidation. Once you oxidize, then you lose the functional property. Whereas if you can encapsulate them into this protein shell, they are completely protected from the environment. So the functional properties of these materials that are encapsulated are protected from any kind of degradation. And then we can use these microspheres for any applications. And this process only takes like 15 seconds maximum. So you don't affect the functionality of this the fish oil or vitamin or a drug, because by sonicating for 10 seconds, 5 seconds or 15 seconds, you will not be oxidizing these compounds because they are in bulk, large quantities. So their functional properties will not change. So what we have done here is we have encapsulated doxorubicin, which is a cancer active drug. And you can see them, the fluorescence coming from these cancer active drugs. You can also load solid particles like metal particles. And some of these metal particles have medicinal properties, including antimicrobial and other things that can be used for some applications. And what we are able to do is we are able to control the size and size distribution of these microspheres or nanospheres by controlling the forces, shear forces that we generate due to acoustic cavitation. Again, this will take me 15-20 minutes for me to go through the mechanism. But in simple term, what we can do is we can change the power density that we provide during the sonication process. And then I can control the size anywhere between 10 micrometers or to up to 0.1 micrometer. Okay. And the reason for that is for various applications, we need to control the size. For example, if I'm going to inject them into my body for delivering a drug, then the size range has to be 1 micron to 5 micron. Less than 1 micron, the system easily eliminates. More than 5 micron, those kind of microspheres can block their the blood capillaries. Whereas for food applications, they have to be around 20 or 50 micrometers so that you can encapsulate large quantities of the nutrient or any other materials. So simply we can control the size and size distribution. Here it is just some mechanistic details, but I'm going to just skip that because I want to give you some time for asking me some questions. And one of the applications of these microspheres that we have done is for working with a company, a confectionery company, which is called Mondelez. They're also making these Cadbury chocolates. So they wanted to encapsulate some flavors and incorporate them into chocolates and see if we can improve the quality of the flavored confectionery products. So in here, using the same kind of emulsification methodology, I can emulsify the flavor. In this case, you can see strawberry flavor or mint flavor. And once the flavor is encapsulated within a shell, in this particular case, we use dairy proteins like whey proteins, which are present in milk. So we don't add any external agent. to protect these things. That's why, again, this is called a green technology, because we are not adding any external chemicals to do our processing. And once we have encapsulated either the mint flavor or strawberry flavor, then we incorporate them into cocoa butter, and that cocoa butter is used then to make chocolates. There's also another concept that we have introduced this to the company. We can also make these chocolates nutritionally valuable. The cocoa butter is fat, but what we can do is we can replace some of this fat with some nutrients. So rather than only having fat in the chocolate, you can have nutrients in the chocolates. So when the children eat chocolates, not only that they are eating fat, but also they eat some nutritional compounds. Okay. And the same kind of logistics we used to make nutrients encapsulated microspheres for delivering nutrients, in particular in countries which are deficient of nutrients. For example, some of the underdeveloped countries or developing countries, they don't have enough nutrients. And majority of these nutrients are like, fresh vegetables, fresh fruits, and so on, and they don't have access to that. And because it has that kind of value to the humanity, the Bill and Melinda Gates Foundation funded this project. Okay, so what we have done is, in this particular case, using the same kind of encapsulate methodology, we encapsulated different kind of vitamins, different kind of nutrients. And once we encapsulated them, then we incorporated them into flour, like dough, like, you can make chapatis, you can make biscuits, you can make breads, kind of things. Especially when you make biscuits, you can store them for 6 months without refrigeration, and it's easy for transporting and other things. And the idea here is, even though when you are making bread or biscuits, you will be subjecting the flour to high temperature, these materials are protected. That's what we are showing here. Even after heat treatment, the nutritional value of the material that we are encapsulating, the nutrients, they are completely protected from heat. That means until you start eating them, you don't lose the nutritional value. Okay, and this is being now given back to the Gates Foundation for scaling up. We also gave them a methodology to scale it up to large quantities. In a given day, you can make them 100 kilograms or something to distribute globally, and they are now currently evaluating whether this is commercially viable or not. But what I'm trying to say here is a simple technique that we have developed here not only can be used in commercial processes, but also can be used for improving human health kind of applications. And just give me 1 minute. Recently, we are also looking into some commercial applications, making some emulsion gels. Emulsion gels are, for example, the cosmetics or some medicine or some food products kind of things. Normally, these kind of emulsion gels are made using chemical cross-linkers and using large amount of emulsifiers and other things. We have recently developed a shear-based technology using ultrasound to get rid of all these processes, all these chemical additions, but to make really good emulsion gels. So this process is very simple. What we do is we add, let's assume that that's your nutrient. This is simply skim milk. We just kind of mix them together and then put them into the shear machine, and we get an emulsion gel out of it with no addition of chemicals or anything. Okay. And also we use similar kind of process for improving the separation of biofuels from some plant materials using ultrasound, and also de-emulsification. This is for oil industry without adding any chemicals, separating the oil. For example, if you take palm oil or olive oil kind of things, they have to add chemicals to separate the oil, but without adding any chemicals, we simply developed a technique. We just fornicate, and the oil just separates out from the biomass. So these are some of the commercial processes currently we are working on. We can also use the same kind of process for food waste applications. but because of the time limitation, this is where I'm going to stop so that you have a few minutes for you to ask some questions. So what I have shown you is using simple interaction between sound waves and gas bubbles in a liquid. They generate physical and chemical effects that can be used for material synthesis, functional materials that can be used as green technology, not only in industrial process, but also to improve the health of human beings. Okay, with that, I thank you again for listening to me, and thank Professor Banerjee for giving me this opportunity. I'm happy to answer any questions. Thank you.
Thank you so much, sir. We are grateful to you that you gave us a so valuable lecture. I forgot to mention that Professor Ashok Kumar is the editor-in-chief of the journal Ultrasound Sonochemistry having impact factor 7. I am fortunate enough that I published 2 research papers, 2 review articles basically. That both came in the same issue, but even I published another 3-4 review articles with ultrasound. But frankly speaking, now the concept clear just now from your lecture, sir. Thank you so much for your so informative, and you explained it so nicely. Thank you so much, sir, for it's like a classroom teaching for all of us. Thank you so much, sir.
Thank you.
Now there is one question. One of my colleague, Vajinder sir, raise his hand. So Vajinder sir, can you please unmute and start your video? And
I just want to know, when you are doing encapsulation, the protein folding on the protein air water interface, are we getting a perfect arrangement or just the aggregation?
So, sorry, I think this sound is not clear. Can you please?
Your voice is not clear, Vajinder sir. Can you please repeat once again?
Yes, 1 minute. I have to turn off the video. Sir, when you are doing encapsulation work, like you are just encapsulating, you are making the particle, a PLC type particle, are we getting a proper shape or just the aggregation of that particle? You got it?
No, maybe you can type that question on the chat function, then I will be.
Yes, yes. So, sir, please write your question in the chat box. So, dear participants, other participants, if you have, Sir Bala Subramaniam sir is clapping for your lecture. Thank you so much, sir. And any other participants? If you have any questions, this is a good opportunity for all of you. If you want to interact, then please raise your hand. I'll provide you the required permission. Yes, sir. Yeah.
Okay, I think the question here is during encapsulation, are you getting perfect arrangement or just aggregate? So in this particular case, basically what we have an emulsion droplet. Okay, so the emulsion droplet is the one which is your nutritional compound, and then basically we have a complete coverage of that droplet by the biopolymer. So it's properly arranged biopolymers, and then what we do is we cross-link them. So basically we there may be some intermolecular disulfide bonds formed and so on, but those kind of oxidation process only happens for a fraction of a second, just to make that shell. So it is properly aggregated proteins or biopolymer, carbohydrate or anything around that biofunctional compound, but we do not change anything, any kind of structural change or biofunctional change or functionality change of the material that we have encapsulated. So hopefully that answers your question, Professor Kumar.
Yeah, Bala Subramaniam sir.
Thank you. So it was a really interesting and enlightening lecture.
Can you please speak it a little bit louder, because it's
it is a quite interesting and informative lecture. So
Thank
I have
you.
only one question to ask. So when compared to microwave bubble formation and collapsing, in what way the bubble formation and collapsing occurs in acoustic wave? How you can compare these two phenomena?
Yeah. So in microwave formation, basically the bubbles are forming in large quantities and also much larger size. So you don't have control over the size of the bubble you form, but they also do not collapse very controllably. Whereas in ultrasound, for example, you will be able to control the size of the bubble that you form by controlling the frequency. And also the amount of radicals that you generate or the amount of physical forces that you generate, all of this can be finely controlled or fine-tuned by choosing the right frequency and right power level. All those things cannot be done in a microwave environment. In microwave, pretty much what you do is you're boiling the liquid, okay? Whereas here, it is not boiling the liquid. It is simply growing the existing bubble at room temperature.
Okay, thank you.
Thank you, Balasubramanian. Now, Muhammad Ishaq, I think.
Hello, good afternoon, sir.
Good afternoon.
Hello.
Thank you so much, sir, for your nice presentation. Sir, I have a couple of questions. In your presentation, you have mentioned that the size of a nanoparticles varies, change with the frequency of the ultrasound. Sir, please give some more light on how the frequency changes the decrease the size of the nanoparticles. Whether the frequency may also increase the size of the nanoparticles.
Okay, so what basically, as I told you, in a given system, if I want to control the size of the nanoparticle, then I have to control the nucleation process. Okay, so if I can generate more nuclei, then I can make smaller particles. I don't allow them to grow by fusion or the other way around. So in this case, what we do is when we change the frequency, if you take 20 kilohertz, for example, at 20 kilohertz, when you use 20 kilohertz ultrasound in a liquid, the number of bubbles that you generate is very low. As you increase the frequency, you can generate more and more bubbles because the wavelength is decreasing.
Right, sir.
So you'll have more antinodes. More antinodes means more active cavitation bubbles. That means you are increasing the amount of radicals that you generate because you are increasing the number of bubbles. So when you increase the number of radicals, you increase the nucleation rate. Okay, but when you go to too high frequency, what happens is, even though you may generate more bubbles, because the bubbles are oscillating too fast, there is no time for the water to evaporate. So the amount of radicals automatically decrease when you go to too high frequency. And that is also related to why, for example, we can use ultrasound to scan our body. You know, what we learned today is that you generate large amount of radicals. Radicals can react with, molecules. In this case, for example, if you have DNA, RNA in your body, then you can start affecting them. Then why it is safe for using ultrasound to scan your body? That's because for scanning your body, they are using 10 megahertz, very, very, very high frequency. At 10 megahertz, the bubbles will not even be having time to oscillate. So you won't do any chemistry at all. That's why it is becoming safer when you go to medical ultrasound. So hopefully you can see that by controlling the frequency, we are controlling the number of bubbles, and that controls the number of radicals that we generate. That controls the rate of nucleation.
Thank you, sir.
Thank you so much, sir. Thank you so much, Muhammad. Yeah. Now, is there any questions or queries from any other participants wants to interact? Because our next speaker, Leonardo sir from Brazil, is also joined with us. So if there is no question, so thank you so much, sir. Professor Ashok Kumar sir, thank you so much for your valuable time, and you have shared with us, and I think all the participants learned many things about, and now I personally feel that it's that you cleared many conceptual problems that was not clear earlier. So thank you so much, sir. Thank you so much for your valuable time. Nice lecture. Thank you so much. Thank you.
Thank you. Thank you very much, and thank you, everyone. Bye-bye.
Thank you, sir. So now, ICRTGC Leonardo, sir, can you please hear me?
Yes, I can, Bubum.
Thank you.
Good
so much.
afternoon.
Yeah, good afternoon, sir. Can you please start your video as well?
Okay, I will try to share, and then you please tell me if you can.
I had made you the co-host now, so you can share now your slide.
Okay. Okay.
Yeah, it is sharing, sir. So before, dear participants, this is the last scientific lecture of our this 3 days international conference, and let me introduce sir little bit. Just a minute before. So just a minute. Yeah, so this is our 16th scientific lecture. Professor ICRTGC Leonardo sir will deliver his lecture on rating and synthesis of chalcogen functionalized heterocycles. Let me introduce her. Sir is a professor of Federal University of Pelotas, Brazil, and Professor Leonardo has studied green procedures and prepare organochalcogen compounds. He has made major contribution in the synthesis of phenyl chalcogenides and the chemical modification of naturally occurring compounds by including selenium and sulfur in their structure. Some results of his studies are published in prestigious journals and contributed to the he published so many important research work, and all are in the highly high impacted journals. So with this small introduction, I don't want waste your time, sir. So with this small introduction, I am again welcoming you on behalf of organizing committee. Thank you so much, sir, for your, as you have agreed to provide your valuable lecture here. So now you please proceed. Your slide is easily visible, sir. So you please proceed with your lecture. Thank you, sir.
Hey, thank you, Bubum, for your kind introduction. I would like to start by thanking also Professor Yadav for inviting me to this very nice meeting, and I'm very happy to participate. And I would like to start by showing you where I am now. So I'm in the city of Pelotas, which is located in southern Brazil, near to the border with Uruguay. And I am 15,000 kilometers from you. So it's now 6:30 in the morning, and I confess you that I never given a lecture this early. So if you hear a snoring noise, probably is my neighbor, which is still sleeping. So don't worry about this noise. Well, I would like to start by showing this painting in canvas from a former visiting student, Marina Matista, which passed a few months here in my lab. She is an Italian. Now she's a pharmacist. And this picture she gave me as a gift, and is like a demonstration of what we do in a organic synthesis lab. So this is a heating gun for developed some TLC plates and some water to show that we try to do some clean chemistry. and the yellow part is mainly selenium in the form of diphenyl diselenide, because our group is dedicated mainly to the chemistry of organoselenium compounds. So what I'm going to talk about the synthesis of few heterocycles, which are present in the several marketed drugs or even in the clinical test drugs, but with a glance of the organochalcogen chemistry. So we work to introduce selenium and sulfur groups in such heterocycles, mainly nitrogen-containing heterocycles, and we try to do this in a green fashion. So how we can greening the conventional syntactic protocols to prepare such heterocycles. So I just have a problem to read what are in my own slides. Let's okay here. I need to move this. Okay, now I think it's okay. So I will talk about three. I'm sorry. 3 aryl-sulfenil and 2 3-bis aryl-sulfenil indoles, 1 sulfenil and 1 selenil indolesins, benzothiazoles and benzoselenazoles, and 3 aryl quinoxaline 2-ons. So I will start showing how we can use glycerol as a solvent in organic synthesis, and I will explain why glycerol. And first of all, I would like to remember some statements from Professor Yoji Noyori about green chemistry. So in 2003, in a communication in the Green Chemistry Journal, he stated that we chemists are proud of our ability to create high values from almost nothing on the basis of accumulated scientific knowledge. And also that without green chemistry, chemical manufacturing will be unable to survive into the next century. So these are very strong and remarkable statements. As you know, green chemistry has 12 principles, were coined by Professor Anastas and Dr. Warner several years ago in 1998. And in our lab, we are looking for meet some of these principles, mainly the principles 1 to 7 and the principle 9. So I'm going to talk a little bit about these principles, but first, what we organic synthetic chemists are looking for in our lab. We are looking for the ideal synthesis, even if it is like it's not so easy, let's say. So the ideal synthesis is safe, is atom efficient, is simple. The yield is 100% quantitative yield. It uses available materials, environmentally acceptable conditions, no wasted reagents, and ideally it occurs in one only step. We, of course, this is an ideal situation. We look for make safe, simple, environmentally acceptable, and using available materials. I'm sure that we are making a very great work if we can meet these targets. So regarding the principle number 5 of the green chemistry, the role of solvents. So in pharmaceutical and fine chemical industries, solvents are responsible for 80 to 90% of mass utilization. They are responsible for the major part of the environmental performance of a process, and they also impact on cost, safety, and health issues. So what we chemists are doing to circumvent these drawbacks? There are several alternatives. For instance, the use of supercritical CO2, ionic liquids, deep eutectic solvents, perfluorinated, PEG, water, and the ideal condition, which is a solvent-free process. Regarding the ionic liquids, they are especially useful in the catalytic reactions. This picture is the cover of the Angevin Chemie, published 20 years ago, and it shows clearly, at least for me, clearly, how we can use ionic liquids in our favor in organic synthesis. So in the left, we have two phases. Here is an ampliation. In the upper phase, the reagents, and in the inferior phase, the ionic liquid and the catalyst. So after stirring for some minutes or hours, maybe, you stop the stirring, and again, you have two phases. In the upper phase, the product, and in the inferior phase, the catalyst and the ionic liquid, ready to be used for a new cycle after you just simply remove the product in the upper phase after decantation. So this, for a long time, was considered a very green solvent. And nowadays, we have some issues regarding the use of ionic liquids. An advantage, despite this one I show here, is the fact that ionic liquids are not volatile. So you can separate your product, for example, by distillation also, and your solvent remains in the flask. The synthesis of ionic liquids is quite simple. Is by a metathesis of two salts. For instance, to prepare one of the most used ionic liquids, bimine BF4, you just need to mixing sodium tetrafluoroborate and bimine chloride. So the product is formed quantitatively. The question is, if we consider the synthesis tree of the bimine BF4, it has more than 30 steps. So the synthesis of ionic liquid is not so green. And what about glycerol? Now, glycerol is used, has been used for years in several applications in industries. For example, traditional uses included medical drugs, food products, cosmetics, textiles, paper, paints, lubricants, tobacco, and of course, the synthesis of nitroglycerin. And new applications also have appeared. For instance, in animal feed as supplement, in dust suppressor. This is a very interesting use, because if you converted glycerol in dust and sprayed in railway wagons carrying iron ore, and Brazil is a big exporter of iron ore, you can suppress the powder, the dust that can be for the wagon in movement. So when the train pass in the cities, this dust is very problematic. So some researchers, Brazilian researchers, developed this glycerol solution. So, and other new applications are described, for example, in the plastic, bioadditives, etc. And what about glycerol as a solvent? In 2010, an interesting review was published in Green Chemistry by Gu and Jérôme, describing for the first time an overview in the use of glycerol in organic synthesis. There are several advantages in using glycerol. For instance, the very low toxicity, the biodegradability, the low vapor pressure. Also, glycerol is cheap, is available, and is safe to handle. There are also some problems, some drawbacks. Glycerol is not an universal solvent because his high viscosity. Normally, you need work in the around 60 degree to improve the solubility of your reagents. Also, glycerol is a protic solvent, so the use of strong bases is not allowed. And the coordination properties of glycerol could be a problem when you are looking for using in metal catalysis in some of these reactions only. But you can see that the advantages are very interesting. Well, then because we are looking for greenings, the procedures that we use in your lab, we started to work with glycerol. Also because in Brazil, it's a co-product of the production of biodiesel, as you know, and Brazil has increased the production in the last 10 years. So we have a lot of glycerol, and it is interesting to add value to this co-product of biodiesel. So how we can use glycerol as a solvent, I will show you first in the synthesis of 3-aryl sulfonyl and 2,3-bis aryl sulfonyl indoles, and also in the synthesis of 1-sulfonyl and selenyl indolezines. In the first case, we used selenium dioxide to promote the synthesis of mono and bis-sulfonyl indoles. 3-aryl sulfonyl indoles are described as presenting several biological activities, for instance, as COX-2 inhibitors, and they have similar activity than etorecoxib, for instance, these two compounds, and also as tubulin polymerization inhibitors. And the activity is similar to combestatin A4. These are the compounds that present this activity. But how are they made? There are two main protocols to prepare 3-aryl sulfonyl indoles. The first one, and one of the most common, is this electrophilic cyclization of 2-alkenyl anilines. There are a lot of procedures, most of them using strong and not so mild conditions. For instance, heating for several hours, over equivalent amounts of several reagents, and also they can be obtained by the direct sulfonylation of indoles. For instance, these three procedures, the first one using a organyl disulfide. Here, the method was extended to diselenide, and you can selectively prepare 3 chalcogenyl indoles. More recently, Wang described the possibility to control the reaction to prepare selectively 3-aryl or 2,3-bis aryl indoles. And in this case, he used TBHP in 2 equivalents to prepare the bis substitute, and then 1 equivalent to prepare the 3-aryl, the mono one. This reaction is very effective in preparing these 2 classes of compounds. Well, what we modified in this approach, we try to use glycerol as solvent, and then using selenium dioxide as an oxidant, cheap oxidant, and we were able to prepare by changing the amount of disulfide, 1.1 and here 0.6 equivalent. We were able to prepare selectively the 3-RU using 30 mol% of selenium dioxide, or the 2,3 bis-RU using 60 mol% of selenium dioxide. By this procedure, just a comment here, we published this paper in the Organic Chemistry Frontiers with the participation of colleagues from Italy and Australia, Professor Claudio Santi and Professor Carl Schisser. This work was performed by Samuel and Felipe. Here we can see the several examples we were able to prepare. The yields were varied from reasonable to good. Also, the time of the reaction, as we can see, is a very short. Then from 6 minutes, 4 minutes, and the yield are very satisfactory. And the glycerol after the reaction can be reused if you decide to do. Also, the method was applicable to non-aromatic compounds for benzyl, dibenzyl, and also this furyl derivative could be prepared in good yields. And regarding the bis substituted, we used selenium dioxide 60 mol%, and good results were observed from the preparation of several bis substituted sulfur indoles. And also the time here is not so high, is a little bit higher than the synthesis of the mono ones. After some control experiments, we were able to propose a plausible mechanism for this reaction. Here, Professor Tiago Barcelos helped us with some high resolution mass spectroscopy. And probably what we have here in the synthesis of the mono substituted is firstly the formation in situ of this electrophilic sulfur species. And in parallel, selenium dioxide could be react with the indole. This is the nucleophilic position of indole, the position 3, forming this bis-indolyl selenide. Then bis-indolyl selenide react with the electrophilic sulfur species, forming the intermediate A. We can call this thioselenium ketal. And after elimination of this selenon B and the product, we have a new attack from the indole to this species to form again the bis-indolyl selenide, and the reaction proceeds. So we were able to detect both intermediates A and B, and also the bis-indolyl selenide. So here we have a selenium NMR spectrum showing the bis-indolyl selenide here around 200 ppm, and here the selenium sulfur ketal in around 550 ppm, and here the HRMS of these intermediates, and also here the product. So it's a plausible mechanism, okay? And to form the bis substituted, the same process occurs starting from the mono, the 3-RU sulfur indole. I'm into to find some applications for this sulfur and selenium derivatives. We, in collaboration with our colleagues from the agronomy faculty of Pelotas, also from with Professor Gismeg from Belgium, we try to look some insecticidal property of these compounds. Using a cell-based reporter of the fall armyworm, which is the main pest of corn crop in Brazil. Brazil is the third largest world corn producer. Also, India is a big producer of corn. But in Brazil, we have a small but powerful enemy in the production of corn, which is the fall armyworm. When a plantation is infested with this pest, the loss are very, very big. For instance, here we have some pictures of this, the larvae of this farm armyworm, and in few weeks, a plantation can be completely prejudiced by this pest. This is a report from 2017 showing that, unfortunately, this is endemic in Central and South America, but unfortunately, it's invasive in Africa, causing a loss of damage in 12 countries in 2017. In Brazil alone, $600 million are invested just to controlling infestations. So it's a very problematic pest in corn crops. Its name is fall armyworm because this is the cycle of this pest. In the fall, after development of the crows, it crawls, after development to the ground to pupate in the soil, and then a new cycle starts. And in the summer, the larvae may tunnel directly into the ear of the corn. So the damage are very, very problematic. Here is a small movie showing the speed that they can eat a leaf. Well, so to control, there are several approaches to control the pest, but there is one that could be greener. For instance, using as target the echidazone receptor. The echidasis is the molting. This the exoskeleton of the larvae. When the larvae to grow, it needs to molt. To molt is like here in the movie, if you can see, is to change the exoskeleton. And the larvae produce this hormone, which is the 20H or 20-hydroxyechidazone, which is here shown in the receptor of the echidazone. So the ECR, the name of this receptor, the acronym for it, is a very nice target for develop a new insecticide. In fact, in the 1988, some researchers from the Home and Hess discovered that tebufenoside, this diacyl hydrazine, is a mimic of the hormone of the ecdysis. So this mimic can kill the larvae, the insect, by just by binding to the ECR, to the receptor. Because the insect thinks that it's time to change the exoskeleton, the insect stop to eat and die by just die because he is hungry. He cannot. He is dehydrated also, and then because this we have a selective insecticide because only the insects have this receptor. Mammalian and other natural animals are not affected by this. So in our study, this class of compounds that we have recently prepared, and also some other of our library with selenium, were tested for their activity against in the ECR. So we discovered in collaboration with Professor Gismag from Belgium, UGent, and Professor Zotti and Ciro from Pelotas, that these two compounds, 1 and 2, they can act as inhibitor of the, they are antagonists of the hormone, natural hormone of 20H and PON-A. PON-A is a phytoecdysteroid that is used in several studies to verify the possibility of find new mimics or antagonists of this 20 and is more available. So we have two derivatives of sulfur and indole that are able to inhibit the moth by, in the next slide here. In these arrows, we are looking the site where the asparagine part of the ECR can bind into our molecules. So this is one of the first case of small molecules that can act as a mimics, as antagonists of the 20H or the PON-A or the tebuphenoxide. This is a very interesting result. And the next step is try in the insects to see if it works. Well, another reaction that we are working here and in Brazil is the indolysins. And recently we developed two protocols to prepare sulfur and selenium derivatives of indolysins. Probably the most useful indolysins are the class of sulfur. Sulfur are tunable fluorophores that can be used to in bioprobes, for instance, to detect pH. And these are fluorescent sensors. You can, by changing the groups R2 and R3 and R1, you can change the color that you can observe in different pH. So you have a very selective pH probe. There are also bioactive indolysins, for instance, 3-sulfonyl-indolysine, which is anti-inflammatory. Also 1-sulfonyl-indolysine used. These are three patents. This is used in the treatment of intraocular hypertension. So how we can prepare sulfur substitute indolysins? In 2018, Cao and Zhao described two protocols to prepare both the 2-substitute and mono-substitute sulfonyl-indolysins using TBHP or hydrogen peroxide as oxidant and thiol as sulfur source in DMSO. So we have here the synthesis of 1,3 and 3 substituted. But at that time, in 2018, the synthesis of 1 sulfonyl indolysins was not yet described. So how to prepare it? Our strategy is quite simple. From the sulfur substituted methyl pyridine and bromoacetophenone in the presence of a base, we could prepare the 1 sulfonyl substituted indolysin. So by the reaction of the pyridine with the bromoacetophenone, this pyridinium salt could be formed, and after reaction with the base, this is an acidic proton because both the pyridinium and the sulfur substituents, this anion could then intramolecularly attack the carbonyl, forming this cycle, and successive reactions, acid-base reactions, could then form our product. So theoretically, it's a very nice proposal and simple. But in the practice, in the lab, the best result we have had was 36% yield in this condition of the entry 4. So we decided then to follow some examples in the literature with other substrates, and we have observed that if you isolated the intermediate pyridinium salt and evaporated the solvent, in this, for instance, acetone, this salt could be solubilized in water, and then after addition of a base, you have the product in a acceptable yield, let's say 65%. Then we decided to explore the synthesis of this pyridinium salt once they were not described so far in that time. And we observed that ethyl acetate is the best solvent, and the reaction for 24 hours at 70 degrees can afford the product. And here we have a selection of examples. Good results were obtained, yields from 75 to 80, 81%, and also from alkyl thiols, for example, propyl, the yields were acceptable, and 2 examples with selenium we are able to prepare. These compounds, because they are new, are now being studied for their biological activities for some colleagues from Pelotas. So once, where is the glycerol in this case? We have observed that glycerol is so good solvent as water in this second step, the cyclization 1. Because water, once you use it, you need to clean it. It's not so easy to clean water. In this case, we decided to use glycerol because the reuse could be easier. And then in glycerol, heating at 70 degrees for 1 hour, or using ultrasound as an alternative energy source for 5 minutes, just 5 minutes, we could prepare our compounds in very, very good yields. And here, method A is conventional heating, 70 degrees, 1 hour. And in green, method B, under ultrasound. The yields are quite similar in each case, but the time is drastically reduced if you use ultrasound. The selenium derivatives were also prepared in very good yields. A colleague, Professor Cesar from our department, tested some of our molecules, and for instance, the selenium derivative, the selenium indolysine, was so effective as ascorbic acid in the ABTS radical scavenger. So a very nice result. This molecule and other similar ones are now being tested for anti-inflammatory properties. Well, the second part of my talk is about the use of less hazardous chemical conditions. Recently, we published a review about the use of alpha keto acids as an acyl transfer agent. So normally we deal in the lab with this problem of using acyl halides as acylating agents. These are not green acylated agents, mainly because the preparation and the waste you have, both the synthesis of this acylating and the waste after the reaction are quite complicated in terms of environmental issues. So why alpha keto acid is a good acylating, is considered a green acylating? Because after the acyl transfer, CO2 is the only waste, and depending the reaction, as I will show you, water is the waste. So you have the production of safe wastes, if we can call them this way, and the CO2 can be reused to prepare more alpha keto acid, for instance. So in this case, I am going to show you two syntheses: the synthesis of benzotiazole and benzosilinazole, and the synthesis of 3-aryl quinoxaline 2-ones. Benzotiazole, probably the most known example, is the firefly luciferin. In the presence of the luciferase, it is oxidized and emit, and you can observe the emission of light, mainly in firefly and other species. So luciferin has a benzotiazole here in the structure. There are several others bioactive benzotiazoles. For instance, GW610 is anti-cancer. Fortress is a prodrug, anti-cancer also. This selenium derivative, or the benzosilinazole, is a beta target agent for monitoring earliest stages of Alzheimer's disease. And this is a market drug, riluzole, for the treatment of amyotrophic lateral sclerosis, ALS, a disease of the motor neuron. And here in the right, we have examples of aldose reductase inhibitors for diabetic neuropathy and cataract formation, the treatment of this disease. In common, they are fluorinated in the benzo part, and they have a carboxylic acid group. So benzotiazole, benzosilinazole are important target in organic synthesis because they are very useful for drug discovery studies. In our proposal published in the Eurojoc in 2017, it was one of our first works using alpha keto acids. In this reaction, we prepared several benzotiazoles and benzosilinazoles, mixing ortho amino dichalcogenides, diselenides, and disulfides in the presence of sodium metabisulfite. So in this case, water and CO2 are eliminated from the acylating reagent and from two. So the benzotiazoles were prepared in very good yields, not all the time. For instance, starting from pyruvic acid, only 41%. This is a acceptable yield, because when R here, this is a limitation. I confess there are several limitations using also the alpha keto acid. For instance, when R is heteroaromatic or alkyl, the yields are not so good. But in general, RU derivatives are obtained in acceptable yields. Here also, when we have a chlorine here, the yields are acceptable. And in the case of selenium, the reaction time increase and the yields decrease a little bit. For instance, in the case of pyruvic acid, no product was observed. But here we have a problem, which is the intramolecular formation of an interaction between nitrogen and selenium. In this case, we have a difficulty in to cleave this selenium-selenium bond, and then the reaction afforded not so good yields of the desired products. Anyway, we could show that this acylating agent can be used to prepare such very interesting class of compounds, the benzothiazoles and benzoselenazoles. We also used the alpha keto acid to prepare other class of heterocycles. For instance, in this case, also benzothiazole, but using another strategy. And here, the synthesis of 3-RU-2H benzo oxazinone. Interesting that the formation of benzoxazole was not observed. The 5-membered ring was formed just when we have sulfur here. When we have a phenol derivative, the 6-membered heterocycle is formed. In this case, also, I could highlight that we used a very particular catalyst, we call here ANO, ammonium niobium oxalate. It's furnished by a Brazilian company which explored this ore in Brazil. So this work I just will pass here, and I will show you in more details the synthesis of the 3-RU quinoxaline 2-1s. So also this class of compounds has a large application in pharmaceutical industry. For instance, we have a commercial drug, the Tinex. This drug is used against tinnitus, and is a commercial drug. And we can see here the skeleton of the quinoxaline 2-1. Also, the compound A is active against diabetic. The compound B has anti-cancer activity. Compound C, antidepressant activity. So the synthesis of this class of compounds is very interesting. And the development of green procedures to prepare these heterocycles is desirable, mainly by the pharmaceutical industry. Once they are very concerned with the question of the waste in the production of the active principles. So our strategy here uses the alpha keto acid, orthodiaminobenzene, and also here the catalyst is ANO, and the solvent in this case is PEG 400. We also have several works working with PEG, because PEG is not volatile, is not toxic, so we can use it in a safe way in the lab. And also here we use ultrasound as a energy source, and good results were obtained after just 10 minutes of reaction. As you saw in the former lecture, the cavitation process caused by the ultrasound irradiation can afford a lot of energy to the system. And in this case, this energy can be used to, in only 10 minutes, produce the desired product. So we have prepared a library of compounds. As we can see, the time is 10 minutes for all the examples, and the yields are quite good, 96, 75. In the scale up test, we could prepare in 70% the desired product. And also when we have substituted with electron withdrawing, electron donating group, the product can be obtained. In this case, we have a mixture of 7 and 6 substituted products, but the yields, the total yields are quite good. Here we have 2 methyl groups here, and the products also are good. So we can see here a very steric effect here. The ortho substituted reduced here the case here is the presence of the electron withdrawing a strong neutral group. The yield was not so good. A proposed mechanism started by the complexation of the niobium with the carbonyl of the alpha acetyl acid, facilitating thus the attack by one of the amino groups, forming this amino intermediate, which after intramolecular attack by the other nitrogen, the free nitrogen, to the carbonyl here, form this intermediate 2, which after elimination of water delivers the product we are looking for. The formation of the 5-member cycle instead is not favored in this case, and for this reason 4A was observed only in small amounts and in few examples. Well, in summary, I have presented some very simple reactions here to show how it's possible to greenish the organic synthesis by using, in the first 2 cases, biomass-based solvent as glycerol, also combining with ultrasound, the sonochemistry. In the second part, the use of a new, not a new, but we call alpha keto acid like a sleeping beauty, because for more than 20 years, this compound was lost in the literature. Then it starts to be revisited, and it works well in several acylating and cyclization reactions. We have showed for you the synthesis of benzotiazoles, benzosylinozoles, and also aryl quinoxalinones. I would like to thank to all my co-workers in my university in Pelotas, Professor Perim, Jacob, Alves, Silva, Hartwig, Savenhago, Bruning, Zotti, Barcelos. This is a multidisciplinary team. Also my students, my PhD students, Laura and Luis, my master student, João, my former students, who most of the work I presented here were developed by them. Samuel now is working in a Europharma, and Felipe, which is a assistant professor in the University of Rio Grande. My undergraduate students, Caroline, Carol, Kathleen, and Gabriela, and my colleagues, Claudio Santi, Carl Schisser, Vito Lipolis, Mike Davis, and Giz Mag. Some pictures of my team. We have a strong policy in Brazil of investing in young researchers. So from the first year in the faculty, the student can go to the lab and start to work with some PhD student and starts his research. So normally, when a student finish the chemistry course with at least one paper, a co-authored one paper. This is our investment in the formation of new researchers. So in Brazil, it's very common. We call scientific initiation. So here we have several youngs that in the time of this picture were scientific initiations. Another picture. The map I have already shown you. Pelotas, we have several campi. In here, upper right is the campus of Capão do Leão. The chemistry faculty is here. And in the end, here is our NMR facilities. Some pictures of the city. Pelotas has around 360,000 inhabitants, 200 years old, the cities, our cathedral. This is we call charqueadas, a former fabric of dry meat. And thank you, Professor Bubun, Professor Iadav, and all the agents for financial support and my university for this opportunity. Thank you.
Thank you so much. Thank you so much, sir. Thank you so much for your so nice and so illustrative presentation. I think our participants learned many things about this organochalcogens and the importance of these molecules and their these all are very biologically promising compounds, and you have nicely explained their synthesis and their importance. So thank you so much, sir, once again for your valuable time. Now I'm requesting any other participants who are, if you want to interact with sir, because this is a good opportunity for our participants. If you want to interact with sir, or if you have any queries, please raise your hand. Then we will provide you the required options to unmute. Participants, if you have any queries, please raise your hand. Or you can share your views also. Or you can share your views. So yes, Aditi Sharma, please unmute yourself. Aditi.
So,
hello, sir. Good afternoon. Hello, sir.
Good afternoon.
Hello, sir. Sir, it is a very nice lecture and informative. Even it is very elaborated, and I feel so good right now. I'm interacting with you, and thank you so much for your valuable time. And yeah, sir. Now, right now, I'm visible, sir.
Yes.
Oh, okay, sir. Thank you so much. And your lecture is very valuable for us from new because I am a new researcher. Just started my PhD under Dr. Bhuvan Banerjee, and this is very privileged opportunity for me to interact with you. And even I'm little fumble also. Thank you so much, sir. Thank you for your lecture. Thank you.
Thank you, Adit.
Yeah, Bala Subramaniam, sir, please unmute yourself. And please start your video and speak it a little bit louder. Balasubramaniam sir, can you hear me? Okay. Pramod sir, you can please continue.
Yes, sir.
Yes.
First of lot of thanks to you to collect the lot of best eminent person of the world in this conference. And there are no question to me. I enjoy all the 3 days. Lot of thanks for you and your
those
team.
speakers and the participants. I'm just.
Yes, you discuss another participant. We are discussing separate platform.
Thank you.
Lot of thanks to you, sir. Lot of thanks to you.
Thank you. Now, Balaji.
Thank you.
Please unmute. Start your video as well.
Good evening, sir. Good evening.
Yes.
Good evening.
Good evening, Bhuvan Banerjee, sir, and as well as Eder, sir. Excellent lecture by you, and also very interesting topic.
Sorry, the sound is speaking.
Yes.
Balaji, sir, your voice is not clear.
In the chemistry. Thank you very much for your nice presentation, sir. We are able to follow your lecture very clearly. Am I audible, sir?
Thank you. Thank you, Balaji. The sound was not. I couldn't hear if you did any question. But thank you.
Yeah, KB Goswami, sir, can you please unmute and share your views, or if you have any queries? KB Goswami, sir, can you please unmute and share your views?
Hello, can you hear me?
Yeah.
Yes.
First off, I just congratulate Dr. Babun for arranging such a nice event for 3 days, and there are lots of lectures which covered sustainable energy or green chemistry or pure synthesis and computational chemistry. I am very busy with my schedule in lab and lecture. However, I just spent little bit time in all lectures with busy schedule, and very nice lecture. In last lecture, Sir Leonardo sir's lectures is very nice lecture about the synthesis and the computational studies. So thank you very much, and congratulate all your entire team and Dr. Babun for arranging such a nice event. Thank you very much, sir.
Thank you.
Thank you, Goswami. Thank you.
Any participants, if you have any queries to Leonardo sir, please ask that. If you are enjoyed, then I am very happy, because yes, Balasubramaniam sir, you raised your hand. Any other participants wants to interact? Yes, Dr. Samal Kumar Jose. Can you please unmute and share your views?
Yeah, I am very much happy to participate in this such a wonderful seminar. And here I have learned a lot of things as a faculty member from the distinguished scientists all over the world. And really, I also thankful to the organizer to make the such type of webinar. And also especially thanks to Dr. Bhuvan Banerjee also. So that's all. I have no right now. I have no any question right now. Okay, thank you very much.
Thank you, Dr. Jose. Yeah, Ashish Mathuri, you raised your hand, please.
Yes, thank you, Leonardo sir and Dr. Bhuvan sir. I am very enjoyed this lecture. Sir, one question: when you use in beta keto acid, alpha keto acid, and can it proceed via radical mechanism? And we are trying to different photochemical reaction and react with thiophenol, and we are trying different reaction. But we are try radical mechanism, but we could not stability to the radical in this position. So can you suggest how will you stabilize this position or any?
Okay, thank you, Ashish, for your question. In fact, normally this reaction is a radical one. So you form the acyl radical, and then you have the coupling with other reactive species. The fact that we have two options, the 5 and the 6 membered ring, and the selectivity is, for our point of view, due to the different difference in the hardness and softness of the nucleophile. So sulfur is compared to oxygen is a softer nucleophile. So in this case, the possibility of form the 5-membered is okay, is a favorite. And in the case of oxygen, instead, it prefers the attack to the harder electrophile. So in our cases, in that specifically, is not a radical mechanism. We think, because when we used some radical trapping, hydroquinone and or tempo, the reaction goes okay. So it was not deeply studied, the mechanism. Anyway, we in this case we are thinking that softness, sorry, that's my softness and hardness is involved in this case.
Yes, sir. Thank you so much, sir, for nice presentation.
Thank you. In the paper, in the paper, you can access more details in the mechanism in the discussion.
Yes, sir. I will. Yes, sir. Thank you, sir.
Thank you. Thank you.
Thank you so much. Thank you so much, Leonardo sir. It's a great opportunity for all the participants to hear from you. I think our participants enjoyed a lot of this. Now I'm requesting Professor Bimal Krishna Banik sir. He is also present with us. So, sir, can you hear me? Bimal sir.
Yes, me?
Yeah,
if you are talking to me,
yeah.
I can hear you. I was.
Yeah, actually, I'm requesting some other resource person. This was the last lecture,
okay.
So I want I want Professor Bimal Banik to say a few words. Thank you, and after that, this is our validatory session will start. And I just want to share you that more. Yes, sir.
Bobon, it was a pleasure to be here with you, with all of you. Okay, thank you very much for this invitation. I'm very happy, and I'm proud to be here. And I hope in a few months or years, maybe I can visit you and know you in person.
Sir.
Okay,
that will be great for us also. When pandemic is over, so we'll wait for that opportunity to learn many things from you under offline mode.
Okay.
And sir, please help us if you that will be great if we can organize some Indo-Brazil collaborative conference. That also be good for us. So we can organize everything for that. So thank you so much, sir. Once again, thank you so much. Yeah, one participant raised hands. Nisha. Okay, still. Okay, so thank you so much. Now this is the time to for the validatory session. So, dear participants, thanks a lot for your kind patience, and it's a huge, long, total 16 invited scientific lectures was there here in this conference, and it's a 3-day long lecture. So I want to share some achievements of this conference with all of you. So just a minute, let me share my, yeah. So in this conference, see the total number of participants. Total number of participants registered for this conference is 989. Is a huge, and this number, this 989 registration came from more than 700 different academic institutions, maybe some colleges and universities, and 14 participants have joined with registered from abroad also. So under this 989, see in this case 309 PhDs, either research associate or faculties have registered, and then 297 either research scholar or UG or PG students have joined. This is the boys, this is girls, and 20 professors have registered for this conference. And here you can see the exact breakup. 145 UG students, 287 research scholars have registered for our conference. 323 assistant professors have registered for this conference. 50 associate professors, 21 professors, and 40 others. Maybe they are industrial persons. And from chemistry department, 804 participants are related to chemistry, and 185 are related to other department. Now, in this conference, 587 participants during registration, they don't want to participate for the poster presentation, but 411 participants that time decided to present their poster. Now in poster category, in category 1, 152 participants wanted to present their poster under category 1, and in category 2, 200 registered students wanted to present their poster in category 2, that is for research scholar or research associate. Category 1 was reserved for UG and PG student, and category 3 was reserved for the faculties. And 202 such participants have registered and wanted to present their posters. Now I want to share another data with you. This is the total. I am very happy that this is the total 6,990 participants have responded during each class attendance. We have so it is almost 700 participants attended these lectures, and I am showing you the breakage. Yeah, this is the third lecture by Sumanlata Jain madam. 546 participants provided their attendance. In 10th lecture, Asit Chakraborty sir's lecture, 535 students have submitted their attendance. In 4th lecture, Professor Bindabar Chandra Ranu sir's lecture, 495 participants have submitted their attendance. In 7th lecture, Professor Sabandeep Singh Chimney's lecture, Sabandeep Singh Chimney sir's lecture, 468 participants have shared their lecture, shared their attendance. In 5th lecture, Professor Angelo Di Fatima sir's lecture, he is also from Brazil, and 447 participants have submitted their attendance. In the 8th lecture, Professor R.K. Sharma sir's lecture, 440 participants have submitted their attendance. In the 13th lecture of Professor Sikand Babu Janalagada sir, 424 participants have submitted their attendance. In Bimal Bonik sir's lecture, 420 participants have submitted their attendance. In Professor Ganpati D. Yadav sir, in the first lecture, 414 participants have submitted their attendance. In Professor For Professor Kamal Yusuf Sadek sir's lecture, 405 participants have submitted the lecture. Professor Ansuda Dia Madam's lecture, 397 participants have submitted their lecture. And for Professor Keglevich, this is the ninth lecture, so 396 participants have submitted their attendance. And Professor Yusuf sir's lecture. So this is for sixth lecture, Professor Unit Sir's lecture. 387 participants have submitted their attendance, and in Professor Basudev Basu sir's lecture, 330 participants have submitted their lectures, and in the 15th lecture, 450 students participants have submitted their attendance, and in your lecture, sir, 394 just completed this lecture. 394 participants have attended either through YouTube or through directly through Zoom. So thank you so much for all the participants. Now we just taking the feedback. Have you gained some knowledges from this lecture? 99.6% attending participants have said yes, and the number is 6,968 times the participants said yes, we have gained some knowledge from this lecture. Only a few, means 0.4% said no, they did not gain. And I this how the rate of means I just to take the feedback, there was a question, rate the conference. 5,010 participants. 5,010 participants said yes, this conference is an excellent one. They marked this as a 10 out of 10. 1,775 participants said it's very good. They marked it as a 8 out of 10, and 207 marked this as a 6 out of 10. So with this, I think it's a huge achievement for us. So now I want to share some just a concluding remarks of all the lectures. I want to share another slide. Just a minute. Yeah. Just a recapitulation of all these lectures. In the first day at 9 p.m. 28th of September, during inauguration, HOD Chemistry Dr. Sandeep Kumar sir welcomes all and shared the information and achievement of Department of Chemistry, Akal University. And then our OD Vice Chancellor sir, Professor Gurmil Singh sir, addressed all the participants and elaborated nicely the importance of this conference and green chemistry. Then Professor Chittaranjan Sinha, Secretary as Indian Chemical Society, enlightened us about Indian Chemical Society and about the Acharya Prafulla Chandra Roy sir. Now, in the scientific lecture, in the first lecture, Professor Ganpati Yadav sir, the President of Indian Chemical Society, his talk title was Practice of Green Chemistry and Energy, the Net Carbon Zero Goal. He talked about in controlling carbon dioxide emissions, hydrogen will play a crucial role, and he talked about the hydrogen is best suited for converting waste biomass and carbon dioxide emanated from different sources. In the second lecture, Professor Bimal Krishna Konik sir, professor and senior research senior professor from Prince Mohammed bin Fayed University, Saudi Arabia. He talked on the topic microwave-induced efficient organic synthesis of medicinally active compounds, diastereoselectivity and enantioselectivity pathway. In the third lecture, Suman Lata ma'am, the senior principal scientist, CSIR, Indian Chemical Society, Indian Institute of Petroleum, Dehradun. She talked about the light-assisted activation and conversion of carbon dioxide to chemicals, a green synthetic group. In the fourth lecture on the same day, that is on the first day, Professor Anu, senior professor from Cultivation of Science, he talked about the functionalization of unactivated CH unit at green concept. In the fifth lecture, the last lecture of that first day, Professor Angelo Di Fatima sir from Brazil, he talked about the calixarin catalyzed reaction And then in the sixth lecture, Professor Yunsul, in the second day, the first lecture, Professor Yunfei Du, he from China, Tenzin University from China, he talked about the applications of hypervalent ion reagent in green organic reactions. In the seventh lecture, Professor Sapandip Singh Chimni sir talked about the bio-inspired organocatalytic enantiosylative carbon-carbon bond forming reaction, and in maximum cases he achieved more than 90% enantiomer excess. This is a huge achievement. And then in the eighth lecture, Professor R.K. Sharma sir, we talked about the Green Chemistry Network Center accelerating innovations through research and educational initiatives in green chemistry. He talked about the various activities of Green Chemistry Network Center in India, and he talked about various research activities, especially applications of liquid carbon dioxide. In the ninth lecture, Professor George Kitlevich sir talked about the various microwave application applied synthesis of various organophosphorus compounds. In the 10th lecture, Professor Osi Chakraborty sir, now he joined us in the cultivation of science. His talk title was application of green chemistry principles on pharmaceutical research, and he showed various aqueous mediated organic transformations and mechanism of on-water reactions. In the 11th lecture, Professor Ansu Dandia madam, former head and department of head of the Department of Chemistry, University of Rajasthan, he talked about the moving towards the sustainability future of chemistry on the wheels of green catalytic technologies. He showed various techniques, green techniques for the synthesis of various biologically relevant heterocycles. And today, in the first lecture, Professor Basudev Basu sir, that is the 12th lecture, he talked about the various functionalized graphenes and nanocomposites in catalyst and catalytic support, and applications of graphene and graphene oxide for the synthesis of various biologically active heterocycles. In the 13th lecture, Professor Sikandi Janadakata sir, he talked on the metal oxides and nanocomposites as recyclable catalyst for synthesis of water treatment. And in the 14th lecture, Professor Kamal Yusuf Sadiq sir from Egypt, he talked on the synthesis of biologically relevant heterocycles, and for that they applied some green tools like solar energy. He discussed all these things. And in the 15th lecture, Professor Muthayapan Ashok Kumar sir described the ultrasonic and sonochemistry as a green technology for functional materials and bioprocessing. And in the last lecture just now, Professor Edith Leonardo sir described the greenings and the synthesis, green protocols for the synthesis of various organochalconides. So thank you so much, sir. In our category 1, we received 24 posters, and in category 2, we received 100 posters. That is for research scholars, and in category 3 we received 58 posters. So with this, I'm requesting our Dean Academic Activities, Professor Major General Lamba sir. Sir, now over to you, sir. You please conclude the entire conference. Over to you, sir.
Thank you, Dr. Bhuvan. Very good evening, ladies and gentlemen. It's my privilege to give the vote of thanks for a very, very successful international conference on recent trends in green chemistry conducted over last 3 days in collaboration with the Indian Chemical Society. In Gurubani, it is said, Pavan Guru, Pani Pita, Mata Tarat Mahat, meaning the importance of Mother Nature in our life, where Pavan, the air, is treated as Guru, water as the father, protector, and Mother Earth is the basic supporter. So to protect our Mother Nature from the ever-increasing chemical pollutants, scientists are restlessly developing modifying the chemical processes to make them sustainable. Under this basic preview, the interactions with the distinguished scientists definitely has given a great opportunity to all the participants to learn many new things of today's research and the direction in which the research is proceeding. For many, green chemistry may have been a fiction, but now it is very clear that it is no more fiction, and the kind of research which is happening in this field is definitely going in the right direction, though at a pace which needs to be further strengthened. We are very much thankful to the prestigious Indian Chemical Society, which was founded in 1924 by Acharya Prafulla Chandra Ray, for giving us this opportunity to organize this level of mega event in the form of the international conference. In spite of the COVID pandemic, the kind of response for papers, for the participants, as well as for the resource persons, it has been really great. And on behalf of the Akal University, myself, and the Department of Chemistry of our Akal University, the organizers, I would like to convey my deep gratitude to all participants at the first, and then all speakers, the experts who have been a great strength to make this conference successful. As already briefed by Dr. Bhuvan, that a total of 999 participants have registered for this conference from more than 700 different educational institutes, universities, including many participants from abroad, which is a huge achievement for all of us in itself. And we are very much thankful to all the participants to make it happen. It is a kind of record in this particular university, and I'm sure for many more conferences to come, it would be an icon. We are very much grateful to Padma Shri Professor Ganpati Yadav, President, Indian Chemical Society, Professor Chitranjan Sinha, the Secretary of Indian Chemical Society, Professor Suresh C. Ameta, the past President of Indian Chemical Society, Professor Dulal Mukherjee, the Advisor of Indian Chemical Society, as well as certain guests from abroad who have been a great strength during this conference, as Professor Mamurao Koketsu from Japan, Professor Bimal Krish Banik from Saudi Arabia, Professor Rajinder Singh Verma, Professor Georgi Kagvich, Professor Samresh Bhattacharya, Professor Girija Singh, Professor Ashok Bakshi, for their valuable guidance and support. I am also grateful to all the distinguished speakers with the list which has already been spoken to by Dr. Bhuvan, and without taking much of your time, I'm taking the liberty of not repeating their names here, but individually, I would be conveying my sincere gratitude to each one of them for making this conference a big success. Also, to our sponsors, the Graduate Publishers Germany, and the convener, Dr. Bhuvan Banerjee, along with the organizing committee members from the Akal University, various faculty members, along with their advisory committee members of the international level. To mention few, Professor Kamal Sadak from Egypt, Professor Shrikant from Durban, Professor Edrjao Leonardo from Brazil, Professor Yonefi Du from China, Professor Angelo Di Fatima from Brazil, Professor Boris Karisov from Mexico, Professor Hojat Vasi from Tehran, Iran, Professor Mohammad Raza from Korea, Professor Ali Ramazani from Iran, Dr. Helen Palissier from France, Dr. Evelina Colesino from France, and our national supporters who have helped us to organize this great event at this of this size and response. Once again, I am really grateful to the organizers of Akal University, all of them without whose participation and full support, this 3 days event wouldn't have been so successful. And on top of it, I would like to once again thank all the participants who have participated so proactively and attended most of the sessions. I'm sure they would have benefited from this in a big manner. And I would personally like to also see a way forward coming out of this conference, which can be of great advantage to the faculty and staff members, not only of the Akal University, of institutions from other institutes also. Thank you very much. Jai Hind.
Thank you, sir. Thank you so much for your nice word. Now I'm requesting Professor Christiana Smith, ma'am, from DeGruyter Publishers, and I'm welcoming you, ma'am, as a sponsor for this international conference. Now I'm requesting over, ma'am, please start your presentation. She wants to present some presentation about DeGruyter Publisher.
Sure. Thanks so much, Dr. Banerjee, for inviting me to speak to you all today. Just a bit about our company, and then I'll announce, I guess, the finalists for the prizes in the 3 poster categories, which we are gladly providing. So as Dr. Banerjee said, my name is Christine Smith. I'm an acquisitions editor in the book department at De Gruyter, which is an international academic publisher. So a bit about our publishing house, some key facts in case many don't know who we are. We've been around for quite a long time. So we were established in 1749 by Walter de Gruyter in Germany, here where I am currently. We have offices worldwide in Berlin, Basel, Boston, Munich, Beijing, Warsaw, and Vienna. We have around 380 employees spread out around the globe, not all at our offices. Some are also working from home during this time. And our namesake, as I mentioned, is Walter de Gruyter. And so he founded the original company, and then we eventually acquired more imprints as time went on. Last year, we made around 72 million euros. So that gives you an idea of the size of company we are. We hold 8 imprints, with the main one being the De Gruyter brand, but some others are Burghauser, De Gruyter Oldenburg, and others. We're one of the largest open access book publishers worldwide, and we also hold many open access journals. And we recently launched a new website this year, updated, that has greater search functionality, a better web shop, and we're going through basically a digital transformation within the company at the moment. As I mentioned, we have offices worldwide, so this gives you an idea on a map where we're located. I personally work out of our headquarters in Berlin, but as you can see, I'm home today because of the current situation. Again, to give you an idea of the size of our company, we publish around 1,500 books, new releases every year across many different disciplines, which I'll get to later. We have 330 subscription journals, and 100 which are open access as opposed to subscription. We have quite a lot of data hosted on our new website. We have 70 different databases and online reference works. We have several publishing partners, which I'll explain a bit more about them in a minute, but from their titles, there's an additional 3,000 titles published per year. I already mentioned our employees, and we've been around for about 270 plus years at this point. Already mentioned our locations. We have 50,000 archive titles. So we've been around for quite a while, and recently we went through a digitization of all of our archive titles where we scanned them and made them in a digital form. As you can imagine, there was a lot of physical books to get through, so that's just ending now. We have, as to date, over 3,500 open access book titles, which you can access at diverter.com free of charge, of course. In a month, around 200 million come to our site, and there's 16,000 articles from all of our different journals published each year. We have many different partners that we work with. I thought the one that was most relevant to this audience is that we're the publisher for IUPAC. So we publish their journal Pure and Applied Chemistry and Chemistry Teacher International, as well as their magazine Chemistry International. And then here are some of our other partners. So a bit about our portfolio. Like I mentioned, we publish in many different subject areas throughout the humanities, social sciences, science, technology, medicine, arts, and architecture. To this audience, I think obviously chemistry, industrial chemistry, and material science are the most important, and actually those are the subjects I'm responsible for in the books department. We publish books, journals, and databases. To get things in a bit more depth, I'll focus on the books first, which is my particular role, so I find it more interesting. For the different publication types, we really do publish a wide range. So from things that are very technical, like manuals and professional titles and directories, we also publish monographs, which may contain a collection of review articles, for example. We also publish textbooks at a graduate level in English and undergraduate level in German, and titles in our special STEM series, which is good for those early career starters and those in industry. We also publish reference works and a few other types that you can see here. In the journals department, we have several top journals. I'm not going to list them all because it would take too long, but I thought I would pick a few that might be relevant to this audience. Pure and Applied Chemistry, which I already mentioned, is the journal for IUPAC. We have Nanophotonics, which this year finally broke through. I think their impact factor is now above 8. So it's one of our highest impact factor journals. We have Green Processing and Synthesis. I think that's really an obvious choice for Green Chemistry Conference as well as Open Chemistry. And I think of these 4, all is open access except Pure and Applied Chemistry at the moment. For databases and online reference work, we have a few that are on offer. These are basically collections of either articles or data that you may access, and we have them again throughout our subject areas. Some that I think are again relevant for this audience is IUPAC Standards Online, which in 2021 I think you can get for free if you have access via IUPAC. And then we also have some German databases. We're originally a German company, so we have some Physik Online and Inorganic Chemistry Online. But probably the IUPAC one makes the most sense for this group. As I mentioned, we're a leader in open access in the books department. We offer, as I mentioned, 100 open access journals. And we're hoping to get more and more open access books in the books department itself. Right now, there's around 3,500 books on the website, but actually most aren't coming from the STEM department. Many are coming from humanities. This is a quote from the CEO of the company. So open access is much more than just a business model. It is our future and our passion. I think this is really relevant in today's climate. Here's a bit of the breakdown of where the open access books are coming from. So you can see about 80% are coming from humanities, and the ones that would be coming from the STEM department currently holds around only 6%. This could be for a few reasons. Humanities publishes more books in general, since that's a requirement for their research, whereas ours is more journal-based, but hoping to increase the amount of open access books. If you want to talk to me about that more later, feel free. Obviously, to have a large amount of open access titles, we need to work with open access partnerships that can help fund the open access books themselves, because someone has to pay, and it's ideal if it's not the editors themselves. So here are some organizations we work with to try and get funding for open access titles. I mentioned we have a publisher partner program. This is where we work with some prestigious university presses to host their titles on our website and help promote them a bit more. We have ones from beginning with Harvard and then other Ivy Leagues such as Princeton, Columbia University, and several others. You can see them all here and kind of the timeline of how we began the partnerships with them. For our services, which I think is particularly important for any of you who are considering publishing a book or journal with us. For marketing services, we send out email campaigns. We have dedicated product pages on degroder.com, which now you can use as web shop to buy the physical and ebooks. We have several different social media channels where we can reach over 70,000 academic followers. We provide review copies of both our journals and books to those interested. And of course, we like to provide some advertisement in digital events and conferences such as this. We also offer abstracting and indexing for all of our journal articles and ebooks so that it's shared effectively on the internet. And we'll try and use some search engine optimization to make sure that it can reach the widest market as possible. For social media, we have several different channels. At the end, I'll give you the information for the general DeGruyter Physical Sciences one, which I help operate. But you can see we have several different avenues to promote your work. We also have a blog, DeGruyter Conversations, where we spread more like popular science type articles that can reach a large audience. And if anyone's interested in writing a blog post for us, just simply contact me and I can see what we can do about that. We also have sales teams worldwide to help promote your work when it comes out. So obviously our offices don't hit every continent, but by having sales teams throughout the world that are working remotely, we're able to get quite a wide reach. And now that my information about DeGruyter is over, probably I get to the part that everyone's excited to hear, which is the poster prizes or the competition with this conference. So we're offering 3 different title options that'll go to first, second, and third in each of the categories. For first prize, we have Green Chemistry and Technology, this monograph style book that came out this year by Mark Benvenuto and George Ruger, the latter of which sadly passed away earlier this year as well. We also have a title from our STEM series on mechanochemistry, edited by Evelina Colasino and her co-editors there. And lastly, we also have a graduate level textbook on green chemistry written by Musivi and his co-author, or sorry, their co-authors. And this one I should mention, the release date is in October 2021. So those that receive this book will have a slight delay when getting it as opposed to the other titles, but I think it will still be an exciting read for those who receive it, worth the wait.
Also, ma'am, now I think this is the time to announce the prize winners. So yeah. Let me.
I also have the information you sent me on the next slides, Bubun.
Yeah, but before that, I need some. I want to get some input.
Sure.
Dear participants, actually we send all these your posters and abstracts to one of I can't disclose the name. One of the speaker, a renowned speaker, and we requested him or her to judge the participants, and we are very much thankful after doing a lot of hard work, because he evaluated in category 1 around 29 posters, in category 2 100 posters, and in category 3 56 posters. So after evaluating all these posters, we requested him or her to provide the first 5 posters, first 5 participants' name. So from each category. So he or she has provided that last night to me, or the Vice Chancellor sir and Dean Assistant Registrar sir. We are very much thankful to him or her. And now, so after this, Madam will disclose this result, because this result I have shared with Madam. Madam will disclose this result. So dear participant, this is not the final. See, if the first, second, third have the minimum attendance 75, then they are the winner. But if from the first, second, third, they don't have the required minimum attendance, that is 75%, means out of 16 scientific lectures, if he or she not attended minimum 12, then he disqualified from the prize. Then we again opt from the 4th and 5th position. Means if first is disqualified, then second will be the first, then third will be the second, and fourth will be the third. So I think you will understand now. Now, Madam, please now disclose the first 5. After that, I will on live, I will check their attendance.
Okay, so I'll go to category 1. So here are the positions that was determined for category 1. Maybe, Bunbun, I don't know when you want me to move to the second, or should I go through all of the titles, or do you want to?
Yeah, you can mention the poster number.
Okay, so in position number 1, we have poster number 7, which was given by Miss Janvi on 5-hydroxymethylfuran synthesis and its applications. In position 2, so place 2, we have poster number 4, which was given by Miss Aditi Singh on the preparation of green and renewable gold saline nanocrystals at carbon catalytic degradation of hazardous pollutant dyes. In 3rd place, we have poster 22 by Mr. Shanrakant Sahu on BVMOs as biocatalysts. In 4th place, we have poster number 6 with Ms. Megha Yadav on recent trends in green chemistry, rethinking plastics in a circular economy. And in 5th place, we have poster number 20 from Ms. Lalita Devi on green chemistry.
So thank you, ma'am. Now, can you please stop sharing, because we must go from category 1, category 2, category 3. So now we need to finalize the category 1. And for that, I need to share the entire attendance sheet. So please, yeah, I need to share my screen now.
Go for it.
Yes, this is the total response we have received. Total 7,018 right now. I must stop accepting response now, because after disclosing this result. Yeah, first is Janvi. The rule is, if Janvi's attendance is below 75, then the second will be the first. Or if Janvi qualifies the minimum attendance, then Janvi will be the first and he will get the prize. Yes,
yeah.
Ma'am? Okay, ma'am?
Yeah.
So now I'm just searching here.
Yep.
Is it visible, ma'am? Yeah, maybe Janvi's name, maybe some others name also. So that's why I am searching mail ID, because maybe some other Janvi may present.
Yep. And Akal University is the correct.
Yeah, so 12 times Janvi presented. So Janvi, this is one time for lecture 1, Janvi lecture 2, lecture 3, lecture 3 for second time, lecture 4, lecture 5, lecture 5 again. lecture 14, lecture 16, again lecture 16. No, I think there is, if I search Janvi, just a minute.
Sure.
Yes, Janvi with Akal University, this mail ID, one time. Scientific lecture, okay, this Janvi is also. First lecture, second lecture, third lecture, fourth lecture, fifth lecture, sixth, seventh, 8, 9, 10, 11, 12, 13. So that means she qualifies for the minimum 75 lectures. So so Janvi is the first winner, and now then the second. Ma'am, can you please mention the name?
Yeah, Aditi Singh.
Aditi Singh.
Yeah, ADITI.
Aditi Singh from Marwadi University. Yeah, she attended
Yeah.
lecture
That's
1,
correct.
scientific lecture 1, then scientific lecture 2, scientific lecture 3, scientific lecture 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So means maybe she filled up the form number of times, but at least this number I have checked is number. So she also satisfied the minimum attendance. So she got the second prize. Now, ma'am, the third one.
Chandrakant, spelled
Chandrakanta
CHAN.
Sahu.
Yeah, Sahu. Yeah, that's correct.
Yeah.
Yeah.
So
yeah.
this is Chandrakanta Sahu attended. Just a minute.
Because that's at the end.
Yeah, Chandrakanta Sahu attended first lecture. Again, first lecture, second lecture, third lecture, fourth lecture, fifth lecture, sixth lecture, seventh lecture, eighth lecture, ninth lecture, 10th lecture, 11th lecture, then 13. So 12th lecture means 14, 15. Okay, so that means in the first category 1, the first, second, third is the winners. So I'm sorry for the fourth and fifth. They are
honorable mentions.
They'll get certificate, but they will not get the prize. And the third, this Chandrakant Sahu will get his book after maybe 2 months after publication of this books. These books will published in October. So after that, you will provide this. Yes, ma'am.
Yes,
and
that's correct.
First and second will receive this book, their books within 1 month. I'll provide their details to you, and you please you communicate them and confirm that you will provide their books. Thank you, ma'am. Now, now I'm stop sharing again. You please share the second category winners.
Yes, excellent. Okay. Oh, there we go. Okay, so category 2.
Yes.
Have here. Oops. Ooh, no, not yet.
You just mentioned the poster.
Yeah, sorry. Oh, I don't know why it did that. There we go. So in first place for category 2, we have poster number 39 by Suman Pradhan on nitroarene catalyzed C heteroatom bond forming reactions. In second place, we have poster 11 Sonam Parha. I apologize also if I'm pronouncing anyone's names incorrectly. On sodium chloride induced cosmotropes perturbation, a prerequisite for Ugi-azide reaction in aqueous media. In third place, we have poster number 26 by Dr. Gurpreet Kaur on camphor sulfonic acid catalyzed, a simple, facile, and general method for the synthesis of 2-aryl benzothiazoles, 2-aryl benzimidazoles, and 3H-spirobenzodithiazole 2,3-indolin 2-ones at room temperature. Really making me work for it. I love it. In fourth place, we have poster number 1, Nicoletta Hersagi on microwave-assisted direct esterification of alkyl and dialkyl phosphoric ester acids. And in fifth place, we have Mohammed Abd El Monem on controlled microwave-assisted reactions of facile synthesis of polyfunctionally substituted phthalazines as dual EGFR and PI3K inhibitors in CNS SNB 75 cell line.
So thank you so much, ma'am. So first name is Suman Pradhan, second name is Sonam, and third name is Dr. Gurpreet Kaur. So if they satisfied the minimum 75% attendance, then they are the winners. If they not, then we have to choose from the 4. So now please, ma'am, stop sharing. Again, I have to check their attendance.
Go for it.
Yes, first is Suman Pradhan.
Yeah, S-U-M-A-N. Suman Pradhan.
S-U-M-A-N.
Yep. Yep. This is the correct name.
Yeah. Okay. So Suman Pradhan attended first lecture, then third lecture, then fourth lecture, then fifth lecture, then again this is the fifth. So oh God. He attended only fourth lecture. I'm again once again checking this. 1, lecture 1, lecture 3, lecture 4, again lecture 5, and then again lecture 5. 1, I'm again cross checking this because here Suman Pradhan is showing 2, maybe S Pradhan. So I just want to check with his mail ID also.
Yeah, in case they wrote their name differently in some check-ins. No, I think this is
again,
still
this
at
is
5.
also 5th times.
Yeah.
So we are sorry, very sorry that Suman Pradhan is not qualified for this first position. Now, if the second position means Sonam, if Sonam attends the more than 75%, then she will be the first winners, and then Dr. Gurpreet, the third, will shift to first, the second, and the fourth will move to third. So let's see with Sonam.
Yeah, S-O-N-A-M now.
Sonam, ma'am, surname?
Surname is Parihar.
P-A-R-I?
Yeah.
P-A-R-I?
Yeah.
P-A-R-I-H-A-R.
It's this one. Yeah, this is correct.
I must, let's see. So this is Sonam Pariyar, attended lecture 5th, 1, then 6th, then 7th, then 8th, then 9th, then 10th, again 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4,
So, and then we're back at
5, 6. That means he or she attended almost all lectures. So congratulations, Sonam. You will become the winner, first position. As Suman Pradhan not qualified because of his poor attendance. So we'll be the first winner, and then let's check the Dr. Gurpreet.
Yeah, Gurpreet Kaur. Yeah.
Yes, Dr. Gurpreet Kaur. Along with name, yeah, Dr. Gurpreet Kaur attended like scientific lecture 4, 1, then scientific lecture 5, second, then 6, third, then 7th, 4th, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4.
And then we're back at the beginning.
So I think sequence. So she got the second prize. Now we have to check for the third prize. Ma'am, please mention the fourth position.
Yeah, the name is Nicoletta, spelled Nikoletta. K.
O. Yeah. Nicoletta.
This is the correct name. Yeah.
Yeah.
Oh, from Budapest. Thanks.
So Nicoletta from Budapest University. She attended lecture 5. This is 1. Again 7, 2, 3, 6, 4. Just a minute, ma'am. There may be something wrong. Just a minute. I must start from the beginning. This is lecture number 7. So 1, 2, 3, again 7. So not 8, 9, 4, 5, 6, 7, 8, 9, 10, 11, and 12. More than 12.
Perfect.
So C becomes the third. So the winner from this category 2 is Sonam as the first, Dr. Gurpreet Kaur is the second, and this Nicoletta is third. So congratulations to all of them. Sonam and Gurpreet will receive their book within 1 month, and this Nicoletta will receive her book maybe after maybe at the end of the December.
Yeah, this might take a bit longer.
Thank you so much, ma'am. Now just one category left. Please share
Almost
the
there. Yeah.
Yeah.
No worries.
Category 3.
Yeah. Okay. Go. Okay. For category 3, in first place we have Dr. Avula Srinivas, poster number 5, and the title of the poster was Microwave Assisted Synthesis of Hybrid Heterocyclics as Potential Anti-Cancer Agents. In second place, we have poster number 21 from Dr. Nidhi Gu on quantum chemical ADMET docking and dynamic simulation studies of hydroxybenzoic acids as multi-target agents against cancer and inflammation. In third place, we have poster number 26 from Dr. Shayamal K. Jash on computational and docking studies of 5,6-dihydroxy-7,8,4 trimethoxyflavone alpha glucosase inhibitory constituent from Limnophilia indica. You can see when it's like the more chemistry things, I can say it easily, and then we get to biochemistry and it's gone. In fourth place, we have poster number 4 from Professor Kantharuju Kamana on a green solvent catalytic for many organic transformations. And in fifth place, poster number 20 from Dr. Yujbal Das?
Yeah.
Did I say that correctly? I'm not
Yeah,
sure.
yeah.
On bromination and aromatic nucleus, a greener approach.
So, thank you, ma'am. And now, according to you, the first position is for Dr. A. Srinivas, and then in second, can you please share once again? Because
Oh yeah, sorry, I can. 1 second. Sorry, I thought we were ready to go to the next stage.
yeah, this is A. Srinivas. Yeah, second is Dr. Nidhi Goel, and third is Samal Kumar Jos. Fourth is Kantharaju Kamanna sir, and fifth is Dr. Ujjwal Das. So now, if the first three secure the minimum attendance, then I'm sorry, fourth and fifth no meaning. But if this first three means if anyone has less attendance, then we have to choose any other position from four. So first, this now I want to share the attendance link.
Yep. Very interactive poster giving session.
Thank you so much, ma'am. Now, Dr. Can you please?
Yeah, AVULA is their first name.
Take me 1 minute. AB.
AV. V like
Okay, AV.
sector.
Okay, okay.
Yeah. ULA. Maybe take away the doctor.
No, can you please mention the surname?
Yeah. There's missing an A on the first name, and then it's SRINIVAS.
Oh, just a minute, ma'am.
Yep.
SRI.
NIVAS. Yeah, maybe take away the.
Yeah, Dr. A. Srinivas. So
use the email for sure.
Let me check with his name, and then we'll check with full name, and then we'll check with mail ID.
Yeah.
With A. Srinivas, only one.
Yeah, so maybe try the email. But
Maybe
it looks like the email is written a bit strange, like there's spaces. Right, because there's a space after Vula and a space after the last name, so it's not.
Now with A. Srinivas, sir.
Yeah, I think the thing is they wrote it a bit different.
He presented one scientific picture, one. Nine, 10, 8. Can you please write? Ma'am, can you please note down the lecture number?
Yeah.
Because you have to, you have
Go ahead.
yes, lecture number 9.
Yep.
Lecture number 10. Lecture number 8. Again 9, 8, 10.
But then there was
9,
another
8,
way
10.
that they
only 3, and here also it is mentioning 3. So with mail ID we got 3. Now check with maybe, but I think now let's check.
Maybe just search the last name only.
Yeah, yeah. Which Srinivas, Dr. A. Srinivas.
Yeah. And then we'll check each time that it's coming up that it's.
Dr. A. Srinivas.
So that's lecture 1.
Ma'am, you have mentioned the number 8, 9, and.
Yeah. And then I saw 1 for 1, lecture 1, where it was just spelled differently.
No, ma'am, lecture number 8, 9, and 10.
Yeah.
You have noted?
Yeah,
So
I have
here
noted
also,
those.
here also with the mail ID as well as the name, Dr. A. Srinivas, it is also showing 3. With Dr. A. Srinivas.
Yeah, that one here is saying lecture 1.
So you need to check which one.
At the very top in the sheet right there. Yeah.
But this is his name is.
No, the one above that.
Okay, that one lecture.
Yeah.
So you please note, Dr. A. Srinivas attended scientific lecture 1 also.
Yep. Noted. Also, Boon Boon, as a reminder, I do have to go in 15 minutes.
Okay, let's check with Srinivas. Total 18. So this is 1. Dr. Srinivas mail ID is matching. This is
lecture
Dr.
2.
Srinivas.
Yeah, it looks like the same.
2. Ma'am, please mention 2.
Yep, I got it.
Lecture number 6 means he used different names, means with dot. So
yeah,
it's okay.
Yeah, but I got it for number 6.
Yeah. Lecture number 6. Now this time no space. So lecture number 7.
Got it.
Now this time no space. Lecture number 8.
I already have.
Now again 8. So don't mention it. This time Dr. A. Srinivas.
Yeah, but I already have for lecture 9. So
lecture number 9. Lecture number 10.
Yeah. Keep going. Okay, 11 is a new number.
Yeah, 11.
Yeah. Go ahead.
12.
Yep, got it.
13.
Yep.
14.
Got it.
15, because I am noticing the institute as well as mail ID also. 15 and 16. So I think he qualified.
Yeah, that's now 13 lectures. So
yeah, so he qualified.
Yep.
So he is the winner from the category 3 because see, we checked all aspects. So by using mail or he by doing fill up of this form, he mentioned different aspects, but at least mail ID and the institute's name, if it is correct, then still we will consider this. So okay, congratulations, Dr. A. Srinivas, for the first position. Now the second position.
Nidhi Gul. First name is spelled Nidhi. Yes, this is correct. Yes, this is correct.
Okay, Dr. Nidhi Gul from Benares Hindu University. This is actually attended lecture 6.
Yeah.
Lecture 7. Lecture 8. Lecture 9.
Yep.
Lecture 10.
Got it.
Lecture 11. Lecture 12. Lecture 13. Lecture 14. Lecture 15. 16. 2. 1.
That's 13 lectures.
So I think she also qualified. Yes, ma'am?
Yes.
So congratulations to Nidhi Goel madam also. So they will receive their books within 1 month. I'll share their complete email address after collecting from them. And Yes, ma'am. I'll
Yes.
share with you their complete mailing address with
Yes,
you.
that would be appreciated.
Now, for the third position, Dr. Samuel K. Just.
Yeah.
SH.
Yeah.
Can you please?
YAMAL.
Yeah, Samuel K. Just.
This is correct. Yeah.
Dr. Samuel K. Just. Let me check with the name. Otherwise, we will check again with the mail ID. So, just a minute. So, Dr. Just attended scientific lecture. Just a minute.
Maybe use the email.
Let me check with his mail ID.
Yeah, that's nice.
Maybe Dr. Just.
Perfect. Okay.
So once he attended 14 lecture.
Yep.
Please note it down, ma'am.
I am.
Lecture 14.
Don't worry.
Lecture 15, Dr. Samuel K. Just. Lecture 16, Dr. Samuel K. Just. And lecture 3.
Yep.
Lecture 4. Lecture 5. Lecture 1. Lecture 2. Lecture 10. Again, lecture 10, so don't count.
Yep.
Lecture 11. Lecture 12. So, lecture 13. Have you counted it?
I have not yet counted 13. No.
So, how many lectures?
Right now, it's 12.
12. So, minimum 75%
is met.
Yeah. So, thank you. Congratulations, Dr. Samuel, for securing the third position. So, we don't need to go for the fourth and fifth position. So, congratulations to Srinivas sir for the first position, Nidhi ma'am for the second position, and the Dr. Samuel Kumar Jose for the third position. So I thank you so much, ma'am. Thank you so much for your valuable time. Thanks a lot. Thanks for your support. Thanks for your sponsorship. Thanks. Thank you so much. Without your support, it was not possible to conduct this. And thank you so much, ma'am. Now I'm requesting if any participant, any winners are present here. Can you please share your views?
Video.
Yeah. Can you please unmute yourself? Any participants, if any winners present here, can you please raise your hand? Any winners?
I see some hands raised.
Yeah, Dr. Samuel Kumar Jose. Please start your video as well.
Hello, sir. Hello, sir. This is Aditi. This side, Aditi is saying.
Yeah, Aditi. Yes. Please start your video.
Sir, can I? Okay. Sir, am I visible? Am I visible?
Yes.
Hi, sir. Hi, ma'am. First of all, sir, I'm really thankful. Yes, sir. Am I audible?
Yes.
Hello. Yeah, sir. Actually, I am from Marwari University, Rajkot. We are a college in Gujarat. And sir, we have really worked hard for this poster and we are so grateful. And so still I am not able to process this news. Still it's not sinking inside that I have got the second position. Thank you so much, sir. I'm so grateful. And it was an amazing roller coaster conference ride these 3 days. I have enjoyed thoroughly. Thank you, Bubun sir, and thank you, ma'am. And I'm still not processing it. I'm still in this process. Thank you so much.
Thank you, Aditi. Thank you for your nice poster.
Yeah.
Now I'm requesting Dr. Samuel Kumar Jose, another winners.
Thank you very much to the organizer and also the ma'am and Dr. Bhuvan Banerjee also. So I am really very happy to hear this news. and I am surprising that I got it, and such type of award enthuses us to make the various type of research work and much more. So thank you very much, the organizer, and also the thanks all the lecture session. So thank you very much. I really have.
Thank you, Dr. Saman. Now I'm requesting our Assistant Dean Research, Dr. Santanu Ghosh, sir. Please say a few words about our conference.
Am I audible?
Yes, yes, sir.
First of all, many congratulations to the convener, Dr. Bubun Banerjee, for hosting a very successful conference. An event of this magnitude is not possible without untiring efforts by him and his team. And I also would like to thank and put on record my gratefulness to De Gruyter Publications for sponsoring the prizes and being a part of this wonderful Green Chemistry Conference, which is a very, very important area of investigation scientific work, because to protect our home through scientific explorations is one of the very basic nature of the scientific community. It's a big responsibility, and I congratulate the conference organizers and others who have participated. So this is not this is my heartfelt thanks also to all the speakers and all the participants, and special congratulations to all the winners of the poster competition. Thank you very much, Dr. Bubun.
Thank you so much, ma'am. Another winners now with us, Gurpreet Kaur. Gurpreet, please unmute yourself and start your video and share your experience now.
Good afternoon, sir.
Yes.
Thank you, sir. Thank you very much. Without your help, it is not possible. And a very special thanks to you, sir, and also to the organizing committee and my lab members.
Thank you, Gurpreet. Now we have Dr. Nidhi, ma'am. Can you hear me? Nidhi. Yes, Sonam. Please start your video.
Thank you so much, sir, for the award. And the conference was quite entertaining and it was so informative for me. Am I audible?
Yes,
you
yes,
are.
you are.
Yes, and it was a great platform. I have been acknowledged. I have gone through the work of Basu sir and Banik sir and Ashok sir. It was quite, I have cleared my concepts about ultrasonochemistry. That was, I've surely published a paper in near future. And congratulations to Akal University for such a great personality at their campus, Dr. Bubun. They are quite lucky for this, and I'm thankful that I made my guide, Professor Anshu Dandia, proud at this platform.
Thank you, sir. Thank you, Sonam. Now I'm requesting Professor Bimal Konik, sir. He is with us from the beginning, almost from the first day. So sir, can you please unmute and share your views at the end about this conference? Bimal sir, can you please, yes, can you please unmute yourself?
I see the video.
Can you hear me now?
Yes, yes, sir. Yes, sir. Thank you so much.
Bubun has become the most smartest man in the world. Yes, because Bubun knows what to say, what not to say in front of young people, in front of medium-aged people, and in front of old people, male, female, young girls, young boys. Bubun is shining everywhere. I am so proud of him. When I started, Bubun started. When I started, Bubun was not even born. When I started my research, Bubun was not even born. Now look, this young man in America, there is a movie called Bambi Grows Up. Bambi grows up. That one small, lovely animal name was Bambi. Slowly he was growing. Parents never knew the child has grown up, and then started to date women. Bobon has grown up so significantly within a very short time. It is amazing, because I have been observing, I have been listening, I have been participating in international, national meeting tremendously, and every week 3 to 5 times. I must say, I have not seen this kind of conference organized by Akal University, Indian Chemical Society, and Bobun is the main person behind all these activities. The main person, all these activities. I have seen most of the posters. I participated in most of the lectures. Everything was so fantastic. Everything was so marvelous. Unbelievable science, future, past, present, prospect on green chemistry and beyond. Green chemistry is just the beginning. After a while, green chemistry may also become blue chemistry. Green chemistry we know what's going on in the surroundings. We like to explore. When we do green chemistry, we see what people are doing in my side, because to see the green, you need to watch in your side. But when green chemistry can become blue chemistry together, you can see only sky. You do not need to know what people are doing in your side. You can start something. The young generation should learn and start something very new from the beginning. Just look at the sky. Do not criticize anyone. Do your job from the beginning. Start new concept, new science, new chemistry, new biology. This conference has become very successful also because of the award. None of the previous, they have annual meeting, they award the faculty, student based on the award, annual contribution, and they have something in special already. But this type of conference, nobody has given any award before. Thanks are due to Christine and De Grooter. Christine is left.
Sir, actually, she has some urgent meeting, so that's why she told me in the chat box.
Okay.
And she requested.
So De Grooter company in Germany has offered this committee several awards for the presenter. That is also very significant, because that helps the students, scientists to become more motivated, to become more interested. What we see this conference, I see more than 300 people every day participated. So that is very huge number, and this may grow further. To cut the long story short, I can say I enjoyed that conference significantly. All lectures, student presentation, everything was fantastic. Arrangement was very nice. The reward for the student and faculty are marvelous. And Akal University, Indian Chemical Society, with the help of many other distinguished speakers, including students, have made this program a huge success. I congratulate all the team, including Dr. Banerjee and the University Indian Chemical Society. I ask them and I request them to continue this kind of endeavor for future and make the student life more rewarding in the future, so that we can have a bright society in the future. Let's do green chemistry and blue chemistry together. Thank you.
Thank you so much, sir, for your continuous support and guidance to organize this conference. Without your support, personally, it was not possible for me to organize this kind of scientific conference. You helped me to collaborate with Indian Chemical Society, and it's I can't express my thankfulness to you, sir. Thank you so much. and definitely we will try to organize a offline mode conference, and definitely it will be our pleasure if you participate in that in India. So thank you so much, sir. Now, any other participants who want to share your views, please? Yes, Rabab Fatima. Yeah, any other participants? Srinivas sir is also present. I think his mic is not working. Any other participants wants to share your views, or have you? If you enjoyed it, then it's fine. I tried my level best to give you a better platform, and for that I requested many, total 16 renowned professors. We are very much thankful to them that they agreed to deliver their lectures in this conference. So thank you.
Hello.
So someone still requesting some poster
Sir,
link.
I'm Govind Rao from Vagdevi College.
Yes.
Warangal. Sir, on behalf of Srinivas, his mic is not working.
Okay.
He won the third prize, first prize in third category of poster section.
Sorry, I can get you. Can you please?
Sir, Dr. Srinivas, I am colleague of Srinivas. We are attending this session right from the beginning.
Yes.
Sir, can you hear me, sir?
Yes, yes.
So he got the first prize in a third category. I congratulate him. I really, the sessions were very excellent, thought-provoking, sir.
So
Excellent.
definitely, sir, if you are a colleague of Srinivas sir, please ask him to say a few words and share his, I think, how he feels like right now. Please.
He is presently is not in position because I think his network connection is very weak. So he intimated me, and therefore, on behalf of him, I am talking, sir. I thank you. Really, he got a wonderful first prize for the third category section, sir. I also represent that such kind of sessions are very thought-provoking, sir. Excellent, and it is useful to all the participants who are really involved in the research work. Thank you once again.
Thank you so much, sir. Thank you so much.
Myself is Sri Govind Rao. Same, we are colleagues of Vagdevi College.
Okay, okay.
Thank you, sir. Thank you.
Thank you. Now, any other participants wants to share? Any other participants wants to share your views? Yeah, Vicky Jain, sir. Dr. Vicky Jain.
Sir, hello.
Yes.
Sir, am I audible, sir?
Yes, you are audible. Please start.
Yes, sir. I'm Vijay Lakshmi, sir, from Tamil Nadu, sir. Tamil Nadu Open University, Chennai, sir.
Can you please start your video? Yeah,
Sir, my camera is not working properly, sir. Sir, this is Vijay Lakshmi, sir, from Chennai, sir.
Can you please start your video?
Sir, my camera is not working properly.
Okay. So please tell.
Okay. Sir, it is most useful, sir. From the first day itself, I'm attending your conference, sir. It is most useful, sir. I'm doing research work in photo catalyst, sir. From the green chemistry itself, sir. It is most useful, sir. Thank you, sir.
Thank you, madam. Will you attend any further conference if Akal University?
No, sir. I'm attend partially, sir. But this conference only fully I'm attend, sir. 3 days from the start itself, sir. So most useful, sir.
Thank you, madam.
Okay, sir. Thank you, sir. Excellent work, sir. Thank you so much, sir.
Any other participants?
Sir, I'm Amit Pandey from Bhagwant University, Ajmer.
Can you please start your video?
Sir, some problem here in my
Okay,
camera.
okay.
Sir, I have joined first time conference and really amazing. Really amazing, sir. Thank you so much, sir.
Thank you. Yeah, Muhammad Isaac.
Hello, sir. Good afternoon. Good evening. Actually, to all of you. I just congratulate organizing committee of Atal University, especially Dr. Banerjee, for organizing such a wonderful international conferences. Currently, I'm at Ladakh. It is nice to. It is my great honor and privilege to be part of this conference, and I enjoyed a lot. I learned new things during the 3-day conferences. Very much thankful, sir, and looking for such a.
Definitely, we are planning. Means in next, if time permits and management permits, then we will organize such international conference in near future, and definitely we will invite you. You are our special guest, because we are after realizing this conference news is reached to Ladakh also. That is a good. I personally feel good that from a participant from Ladakh joining there. Please remain in touch. If we visit Ladakh, then we will meet with you. Thank you.
Yeah, sure, sir. Thank you. Thanks a lot, sir.
Yes, Somo, madam, can you please unmute?
Hello, sir.
Yes. Can you please start your video?
I'm really sorry because of the disturbance.
Okay,
I'm
no
unable
problem.
to start my video. But I would say, I have been into psychom field, and definitely this green chemistry has enlightened a lot because of all the lectures. I actually didn't attend most because of some other work, but the ones that I have attended, they have enlightened a lot. And thank you so much for hosting and being so patient with our attendance and registration. And thank you so much for hosting this.
Thank you, madam. Now, Pradeep sir, can you please unmute?
Okay, sir. I am Dr. Pradeep Shimpi from VNN College, Bhiwandi. I am associate professor, and our college is affiliated to University of Mumbai.
Yes, sir.
Yes, sir. I am very thankful to you that to arrange this webinar, and all resource persons present excellent and informative presentations, and they are update our knowledge. We are enjoying all the 3 days and all the lectures. Thank you very much. I hope in future you also arrange such a international webinar.
Definitely, sir. But actually, this is one of the beneficial part of this pandemic. Otherwise, it will be very difficult to organize such international conference offline mode because of lack of fund. But there is this is the means we are utilizing the pandemic situation in positively, you can say.
And this webinar is cheapest for us, and this time consuming. The time is our not spending here more.
Yes,
so it is very important for us.
Thank you, sir. Now, yes, Dr. N. Latham, ma'am, can you please start your video?
Good evening to all. 3 days international conference is very informative. The excellent work. The presenter, that is paper presenter and resource person, work is very excellent, and huge work is presented at a time. So we gathered all information in 3 days. So the work is very, very excellent, all extraordinary work. So it's this is for my opinion.
Thank you so much, madam. Thank you so much. Yes, Jyoti Singh, madam.
Yes, sir. Good evening and good evening to all.
Can you please start your video, ma'am?
Sir, here some net problem is.
Okay, ma'am.
So I want to say, sir, one thing. It is very great events and organized by you. So thank you, sir, and thank you to all speaker, because we have learned so many things through this event. I want to say one thing, that I want to become again to be a part of such a wonderful event.
Definitely, ma'am. We have the database. We will definitely share any kind of information. We have your mail ID. We will share all of you the communication, the brochure, the link every time whenever we will conduct such kind of activity.
Okay.
Thank you so much. Thank you so much, ma'am. Yeah, Dr. Srinivas, can you hear me?
Yeah, sir.
Yes.
So thank you, sir, so for giving this opportunity. So actually, it is a wonderful seminar, sir. So you are arranged.
First of all, why you submit the attendance form with different types of name?
Actually, sometimes I got the net problem, sir.
First time Dr. Dot A Srinivasan, and anyways, I'm just joking with you.
Yes, sir.
So thank you so much. Congratulations that you secured the first position in the category 3, the most senior most category. Thank you so much for your nice work, which our expert selected your work as a first top. Thank you so much. All the it was, I think it was a very challenging for that concerned person. All the posters are very almost same kind, or all are very valuable. So still we have to choose the first, second, third. So thank you so much. Now Lalita Devi, yes, unmute.
Good evening, sir.
Evening.
I am Lalita from PG, student from GDC Boys Udhampur. Thank you so much, sir. I got the first position in poster making competition in category 1. Not in winner list, but I'm so happy, sir. Thank you so much for this informative lectures.
Thank you. Actually, you made a poster by hand, I think.
Yes, sir. Due to some problems, sir.
Okay, but still, it is very. I'm very happy that selector have choose your poster. Still, because your effort maybe. You make a huge effort to make this poster by sketch pencil or anything else, color.
Thank you.
Thank you. Thank you so much.
Sir.
Thank you so much. Any other participants? Yes, Ranveer. Yeah, Dr. Ranveer, sir. Ranveer, sir, can you please? Yes, can you please? Yes.
Good evening, sir.
Good evening, sir. Oh, what is your background?
Yes, it's due to my son.
I need to buy something. Yeah.
Sir, I feel very happy to see you that organize in a very mannered way the international conference. The quality of resource persons, I think, excellent. And the schedule of and management of the conference is very tight schedule. And everything in managed way, that every lecture have attendance, that you should tight every participant to attend the lecture and bound to gain some knowledge from every research person. So I would like to thank you especially very much, sir.
See, I'm very much sorry that I used some tough words in the WhatsApp group. See, why? Because it is, I think, it was very painful for me, because now you understand how much hard work is required to organize such things. And I am and speakers definitely this highly qualified and renowned speakers, they definitely expect some have good number of participants.
Yeah, yes, sir.
So that's why I sometimes may have used some hard or tough words. I'm sorry for that. But
it is a requirement for a discipline.
Yes, means thank you so much, sir. You understand this. Thank you so much. Thank you so much for your kind views. Oh, yeah, Bidut.
Very nice, sir.
Yeah, Bidut Dubey, raise your hand. Can you please unmute, sir? Yes, Bidut Dubey, can you please unmute?
Hello, Bhuvan sir.
Yes.
Yeah, sir, I have one request. If any other conference like this come up, please do inform us. We would love to join it, sir.
Definitely, we will inform all the participants. Don't worry. You
And
do
sir,
your
also,
work. You
yeah,
do some
and sir, also,
innovative work.
yeah, yeah. And sir, also you have put in one brochure, and sir, we are participating into that also. There is one international conference
Yeah,
now.
for that,
We are
please
participating in that also.
follow Indian Chemical Society website, because I don't have much information. I collected it from those information from Chittaranjan Sinha sir. Now, please follow those regarding this conference. Please follow that. And one thing,
Thank you, sir.
we'll try to provide your certificate as early as possible. Please give us some time, minimum 10 days, because we need a lot of work to design and to prepare all these things. But definitely, we will provide you the certificate. Don't worry. Okay, and your yes.
One last question, sir. You mentioned that we can contribute in the book. How can we contribute in the book, sir?
That we will discuss in through mail. Okay, because I don't in my mind it is completely full of the conference right now. So okay, so
Okay,
you will
sir.
discuss
Yeah.
after 2nd October. Okay.
Thank you, sir. Thank you, sir.
Any other participants? Or you have please share some views about the winner selection. Is it okay? Winner selection, regarding winner selection, do you have any suggestion or views? Any faculty like Madhumita Bandopatro and Manas Rajnas, Dr. Nagaraju, Dr. Neeraj. Dr. Nagaraju, I have a number of times messaged you personally. Please convey, share your views with the speakers, but you never replied. So I think you have not followed my message.
No. I messaged you.
But you
Thank
never
you, Dr.
raised your
Bubin.
hand.
Thank you, Dr. Bubin. Congratulations for organizing such a wonderful international conference. I attended throughout last day sessions and today sessions also. I'm little busy with the first day sessions. I attended only one session only, but sorry for that one in the first day sessions.
Thank you. Thank you so much.
I learned also a lot of things about the how the green chemistry to influencing on the chemical synthesis and all the things. And personally congratulating you. I think I hope to I will attend on the physical conference also in future also. I think I will be in the touch with you. Thank you.
Thank you.
Congratulations.
Yeah, thank you. Thank you so much, sir. Any other faculties? Because your feedback is very much required. Any other faculty? Yeah, Dr. Vicky.
I'm sorry, I'm still
Can
driving.
you please start your video? Can you please start your video?
Yeah, actually I'm in a car, so I hope the video is visible.
Yes, yes.
Thank you, Dr. Baban sir, for organizing such a wonderful conference and inviting the experts which are at high level, and really it was amazing. All the lectures were amazing. Our students participated in this conference and won the prize, won the poster presentation, and similar if this type of the conferences are happening at international level, then definitely each and everyone from this society like Indian Chemical Society will be aware of such things. The youngsters, specifically the research scholars and the students, will be benefited with these conferences. Thank you very much.
Thank you, sir. You must feel proud for your student, and definitely encourage your student to attend. Number of students to attend for our next conference in future.
I received your mail from Professor Sandeep Sancheti, and he forwarded the mail to us, and from him we got this information, and we the faculties as well as the students participated in this conference.
So definitely next time if you organize something, you will the participants will get fast information, because this database we will have, we will definitely use that, and we will provide them the fast day information, so that they get much time. Any other?
Yeah.
Thank you so much, sir. Thank you. So any other participant, any other faculties want to share your views?
Dr. Banerjee, sir, I have a small submission.
Yeah.
Sir, could you please available us the all the poster ranking, so that it could be a basis for encouragement us in the future?
See, it will be very tedious job,
Yes,
and
sir,
it
I
will
know.
be again asked that concerned expert, please share all these things. And
Right.
see, in some means he or she worked at least minimum 5 to 6 hours. You can imagine, means to evaluate at least around 100 posters, it is not a matter of jobs. Joe. So
Right.
we requested him or her to at least provide the best 5. So that is also very challenging, and all the posters are almost parallel in category 3. Definitely category 1 we can expect high quality posters, but in category 3 almost all posters are valuable in their own particular field. So definitely it will be very difficult. I'm sorry, with 100 posters we need to number, this is 100, this is 99, this is, so I'm very sorry to ask him to assign those numbers. Thank you, sorry for that.
Thank you, sir. Right, sir. Right, sir. I understand, sir.
Yes. Any other suggestion?
Yes, sir.
Yes, thank you, sir.
Sir, first of all, I would like to say thank you very much, sir. Bhuvan, sir, you are very helpful. You are very cooperating. First time
I followed your WhatsApp status also with
yeah,
foreigners.
yeah, sir. Yes.
So,
yes, sir.
Thank you so much.
Thank you very much for organizing such kind of conference, sir. Very renowned persons are there. The resource persons are. I can't say a word. I haven't words to say. Highly qualified persons are there, and we learned a lot from this conference. ICC is not new for us, because I am the student of Dr. Harisi Gaur University Sagar, and I was the research scholar there in 2006 to 2010. At the same time, I have attended many more conferences, Indian Chemical Society. For that, I have I went to Vellore for that conference, so I know very well about the Indian Chemical Society. And this conference is very different and effective for us. I am attending a lot more conferences, but this is very different and very unique. Lot of thank you to you, and
thank you so much, sir. Actually, I should not say, but I'm why from where this conference organized.
Sir, it shows lot of.
See, I attended one conference. I will not mention the name of this conference, but one conference I attended, and I found there only 30 participants.
Okay.
With a conference is organized, and with the banner of Indian Chemical Society, on 30-40 participants are attending that. So I felt very bad. As a I am also from West Bengal, and I felt Professor Acharya Prafulla Chandra Ray was also from Bengal, and he founded a society, and one conference it was organized with the banner of Indian Chemical Society, and means only 40 participants.
Yes, sir.
So for that, from that day only, I requested Chittaranjan Sinha sir, and for that Bimal Banik sir helped me out. So
But
from that day it was my challenge. I'll organize a conference where at least I'll try to make at least participants 500. But
it is sir, it is huge success, sir, because number of participants are very high in this conference, and all over the India, not from the India, from the abroad also, they are connected.
Yes.
And we have the winner, that is from Brazil, I think.
No, he secured the she secured no
third position, I think.
Yeah, she secured the third position from Hungary.
From Hungary. Yeah, so it shows what kind of conference this was. Because sir, I am also organizing such kind of events, and I know very well, if you are going to conduct this kind of event free of cost, the people get registered, but they don't want to attend any kind of lecture or any kind of keynote speakers.
See, that is the main problem. I realized I have to do something, or I have to introduce some attendance link. I know I bothered you people, the genuine people, a lot because of this attendance link. But otherwise, I am sorry for that. But otherwise, it was very difficult.
Don't say, sir. Don't say sorry, sir. That is very important. That is very important, because if you don't put this kind of step, the people don't attend the lectures.
Yes.
Because the hard steps you should have to take, and that was good. And I am appreciating you, and I want my humble request with you, stay connect with me.
Definitely, sir. I have always follow your WhatsApp status. Thank you, sir. Ragi Sita madam is waiting. Yes, ma'am.
Thank you, sir.
Thank you, sir. Thank you. Yes, ma'am.
Sir, congratulations, sir. It was an excellent international conference.
Thank you.
Yeah, I have attended several in India and abroad, offline as well as online. So I have attended AAPS at USA, Chicago, and at Netherlands I attended Tetrahedron Symposium. At Dubai I attended the ACSTM. So this is the online conference which I am seeing. This is I can say you have set a benchmark, to the others who are in this field. So it was really good, sir. It is nowhere less to any of the offline conferences. So even though it was virtual, I appreciate your efforts, which are visible. Yeah.
Thank you. Thank you so much, ma'am. This will encourage me to conduct or organize other conferences in future. Thank you so much, ma'am.
Yeah, sir. Nice to interact.
We'll definitely share the information as early as possible with all of you. Thank you, ma'am.
Yes, sir. Thank you. Thank you for the opportunity. Yes. All the best.
Any other participants wants to interact? Sorry, I bothered you with attendance link and all these things, and I am sorry for that. But otherwise, it was not possible. Otherwise, again, in this conference also only 40 to 50% participants will attend.
No, sir, that was a good thing, sir. Yes. That was a good thing, which made the conference, the lectures, the talks, the experts. That was how did you collect all of them? How did you gather all of them? I wonder, sir. It was a real good collection. It's a real bouquet with beautiful experts from all the places around the globe. That was a good, a tremendous hard work, I think, sir.
Thank you so much.
A lot of background work has been done, sir.
All of your word will encourage me to organize such event in future. Thank you, ma'am.
Yes.
Any other participants?
Even the first winner is my colleague, sir. I have to tell you over here, the prize winner, poster prize winner, A.S. Srinivas, sir, is my colleague at Vagdevi. So we are happy for that.
Okay, thank you.
Yeah, thank you, sir.
You must ask for him a party.
Definitely, sir. We are waiting. Yeah, yeah.
Thank you. Thank you.
Thank you,
Yeah,
sir.
any other participants? Because it is already 6. So if you want to share your views, it's okay. Otherwise, we can stop. Bimal Panik sir is still with us. I think Bimal Panik sir is left. We must thank Ansus Dandia madam, who almost attended all lectures. See, these type of persons, I must say, we must learn many things from this type of person, like Asit Chakraborty sir, and you can see the Sadek sir. He is 75 years old, and still he is so much energetic. So this type of this is a good feelings, and we our participants, I think, learn many things from all the speakers. So thank you. So any other participants want to share your views, or otherwise you should stop here. Sorry, I bothered you a lot. Yeah, you can expect your certificate within 10 days. Let me prepare. Maybe I have to prepare by hand. I may not believe in the software. Maybe I have to check your name, your poster presentation title. I'll prepare all the posters by hand. So give me some time so that error-free certificate you will receive. Believe me, and please wait at least 10 to 15 days, because I'll not go my hometown for Durga Puja. I'll provide you the certificate. Don't worry. But please give me at least 10 days. Please fill the accurate form, and we'll definitely provide you the certificate. Any other participants? Still 109 participants are there. Yes, Dr. P. Fagiria, can you please unmute? Because in many times I could not interact with you people. So I'm sorry for that because of the lack of time. So this time we can utilize to know each other. If you want. Arnab Kanti Karan, I noticed you attend almost all lectures. Yeah, Anuradha Patania madam, can you please unmute? Your student contributed number of posters. I remember. Can you please unmute and share your views?
Yes, sir. Yes, sir. So it was really amazing conference I have ever attended.
Is it possible for you to open your video, start your video as well?
Sir, actually, I'm outside my home.
Okay, okay. No, ma'am.
Yes,
no problem, ma'am. Yeah.
But I'm listening everything since from the starting, sir, and it was really.
I noticed. That's why I told you.
And so it's really wonderful. I just, sir, I had just saved your number so that I can contact in personally at the Akal University at your campus as well, because I visited many times over there, but I just nearly in future I want to meet with you.
No, I joined here March 2021, means 8 months before.
Oh my God, sir. And the brilliant work you had did, sir. Really, you had did awesome work, sir. And really, I appreciate a lot. And I gained a lot of things from different lectures as well as from you, sir. Most of the thing that how you are handling, how you are just organizing this whole the international conference, sir. Many, many congratulations, sir.
Thank you so much, ma'am. And your students are working very hard. They describe some medicines, anti-cancer medicines.
Yes, sir.
Yes, we read all their abstracts and posters as well. Thank you so much, ma'am, for your good work.
Welcome, sir.
Yeah, Yochima, you messaged me many times. Now, please. Can you please start your video and unmute? Yes, Bhupinder. Rahul sir. Any other participants wants to interact? Yeah, Arnab Kanti Karan.
Yes, sir. Good evening, sir.
Yeah, good evening.
Sir, I'm Dyotima Bose speaking. Yes, sir. I really enjoyed all the lectures. It was so
Is
like
it
they were all.
possible for you to start the video as well?
Okay, sir. I'm trying. Yes, sir. I have actually enjoyed all the lectures, and it was really so inspirational, so intriguing, and I've learned a lot. And the best part of it was that it was so interactive, and you encouraged the like one-to-one interaction with all the eminent scientists.
Thank you so much. Next time we will definitely share all the information with you, all the participants. So thank you. Yeah, Arnab Kanti Karan, I want to see you because you attended almost every lecture. I noticed, but I never got the opportunity to. Yes, thank you, dear Tima.
Good afternoon, good evening, sir. Can
Good
you hear
evening.
me? Can you hear me, sir?
Yes, yes.
Actually, sir, my laptop camera is not working. So it's a very wonderful conference, and I learned a lot of things from this conference. And thanks to you, and thanks to the Akal University to.
Thank you. You are from?
I'm from Calcutta, Jadavpur University.
Okay, okay. Thank you, thank you. Thanks a lot.
Thank you, sir. Also, thank you this team also.
Yes.
I would like to be part of such international conference again and again.
Definitely, we will invite you. Yeah.
Thank you.
Yeah, Khushbu Sahu. Khushbu, can you hear me?
Hello.
Yes.
Yes, sir.
Yes. Have you enjoyed the conference?
Yes, sir. I'm enjoyed a lot. Conference is very, thought provocative, and it's very useful for us. It's very beneficial for us. I will all next time. Please join this type of conference. If you will organize, definitely we will join, sir. Thank you, sir.
We'll definitely inform you. Okay. Thank you.
Yes,
Any
sir,
other
thank you.
participants? Because we need to, and we must show you the sir Pradeep sir, the entire means he managed the website and all these things. He thank you so much, Pradeep ji. You worked hard a lot, and he need now we need Pradeep ji. We need. I have also